All right, looks like we're live and the computer hasn't died. So let's see. Dangerous. All right, looks like we're live and the computer. Amazing. All right, so far so good. Didn't crash or anything. Yeah, it's got everything this time. Or should be everything, or almost everything. Except I have to figure out which window I'm in and all that kind of stuff. But yeah, I should be able to do the drawing window or this or the text or lots of stuff. So getting very sophisticated until it fails and everything goes to hell. But we'll see. Maybe I'll pop this little window. Okay, it's too big a window now. I had to make the window big so the resolution was better, but I'm learning this stuff. All right, so comments. So you have to figure out if there's a way I can actually see what's live, but it doesn't really matter, I suppose. I'll just check in now and then, make sure something hasn't blown up. So we'll do some comments. So I have started the Professor Lewin style videos, and it went okay. I got through one lecture with just 2 videos, which is pretty good for me. Yeah, it seems pretty doable over time, and I think it'll be productive. But the concepts, again, are a little bit complicated. So, it's I haven't had years to perfect my shtick and my explanations. So I may have to qualify or restate some things because I may state them incorrectly here and there. But the idea of making these distinctions between their model and my model is the real point. The contrast between the two and the fact that their model doesn't explain anything about why it happens. So anyway, so this guy says, you said positive voltage is high pressure and negative voltage is low pressure. Yes, and it's understood relative to ground. So ground is the point. I mean, I did the illustration. Maybe I can actually see my illustration this time, see if I'm doing it well enough. So I'll move this over a little bit so I can see it. Ugh. All right, so if I have 2 things, and one of them is much bigger than the other, which is the proton and the electron, the charge difference. The density of charge is what they would call it. Okay, so the proton's much bigger, electron's smaller. So the proton's in the middle of the atom. You can see there's a point where these 2 things now look the same size. Even this is 4 times bigger than this, let's say, you can see they're the same size. So in the atom, this number is tens of thousands of, the distance is huge. So the difference between the proton and the electron is 1400. So obviously, to make the difference, you'd have to really stretch that out. So the point is there's a point where the 2 of them will look the same. All right, they'll look like they're the same size. This one's big, this one's small there. So they're the same size, even though they're not the same size. They look like they're the same size. And so low pressure would be this. I move the proton back. That was the electron going forward. So that's high pressure. So now the electron looks bigger. So the electron looks bigger now. And low pressure would be this. Proton bigger, electron smaller. So that's what you have to understand. The pressure changes the polarization of the atom. It changes it from being proton heavy to being electron heavy. So when it's pressurized, it's electron heavy. When its pressure is relaxed, it becomes proton heavy. Hope I said that correctly. Anyway, you should be able to get the idea that they're not fundamentally, it's a scale of pressure, but the scale has a definite midpoint where the 2 balance. Well, a point. It doesn't have to be in the middle, but there's a point where the 2 are perfectly balanced. One position where they're the same size, and only one position. And then they go from this being too big to this being too big. All right. A voltage measurement depends on where you reference it from. Now it just depends on what it's relative to. So you can take any 2 points on the scale and create a voltage difference. So the scale from 0 to, say, 50. You can go in any 2 points and you have a difference. Doesn't matter this way, this way, this way. There's always a difference from any 2 points. There's a potential difference. You can switch the leads, sort of irrelevant, but go ahead, and measure positive and negative voltage from same battery. It has nothing to do with high or low pressure. No, you just don't understand. Yeah, it does. Okay, so, and you can really illustrate that with even like the electricity, the high voltage electricity or something like that. Let's see, where, the sine wave dips down and to 0, and it goes back up to a peak. That's all it's doing. It's not reversing. It's just going to 0 and then to a peak, and there's a neutral between the two. So from the neutral's point of view, the 0 is this much voltage, and from the neutral's point of view, the peak is only this much voltage. Now from 0, the peak is much higher. So you would have 220 going across here, 240, and you would only have 120 in each one of these differences. So your emphatic statement is just incorrect. It has everything to do with high and low pressure. Higher voltage is more pressure, and low voltage is less pressure. Yes, period. We're done. But negative 12 volts, sorry, there's no such thing as the distinction of what goes up and what's going down. It's only relative to the ground, so it just doesn't matter. From the ground's perspective, it's 12 feet down. From the ground's perspective, it's 12 feet up. It's the same 12 feet. There's no up and down difference. Anyway, negative 12 is the same as 12 volt positive pressure. Y's just different reference. I don't know what that is. Y is just different. Y just different reference. I don't know. It's not, no period, no question mark, no nothing. I don't know what that means. But negative 12 volts is the same as positive 12 volt pressure. Y is just different reference. Point is I'll just keep stating it. The pressure changes the shape of the atom. And when it's at low pressure, the atom is now essentially a positive ion, a negative ion, sorry. And when it's high pressure, it's a positive ion, essentially. That's all I can say. I mean, I can't force you to accept the truth, but that's the truth of it. I love your channel. Well, that's nice. I mean, you don't have to love it. You can just like it or appreciate it. Love is kind of, yeah. I don't know if that's a good word. If you have a negatively charged object like a balloon and you bring the north end of a magnet to it, what movement would that cause? Well, just by deduction. They always use the negative end of the magnet as the end where the stuff is coming out. And it goes around and comes back in the other end. All right, so none of that's happening. But just as an illustration, I could argue that if we use that logic, the north end would be the electron end. That would be the extra stuff end. So we could say that the north end is the negative end. Okay? And so if you're saying you bring it to a negatively charged balloon, then obviously they would repel. And but the trick is it's going to be tricky because the balloon's very big. Magnet's not going to be very big. And so the magnet's only going to have an effect on a certain part of the balloon. The magnetism is going to be strong on only one little piece of the balloon. And the balloon's magnetism is going out this way. So it's only a tiny bit of the balloon that will be pushing against the magnet. So the magnet will be surprisingly ineffective at moving the balloon because it doesn't have enough volume. It isn't spreading the charge across a large surface. So, and the magnetism. So it's not going to be to scale to the charge of the balloon. So the magnet won't be incredibly effective, but it will move the balloon. I should do the experiment because I don't see how it can avoid moving the balloon, but yes, it will work. It should work. I wish he had done it just to show it. But yes, it should have some effect. It just won't be that dramatic an effect because of the size problem and the spreading of the magnetism and the catching of it. You have to catch it. You know, you can't be affected by it unless you have a net to catch it with. And the little magnet doesn't have much of a net. All right. And then the John Gray guy who just keeps making statements and not saying much else. Certainly not responding to any of my counter arguments to his statements. But anyway, somebody said we cannot see electrons, but electrons are all we can see. So if you think seeing, it all depends on what you're calling seeing, right? Because we don't see it very well. Just like we don't see stars very well in the sky. We're seeing a blob of light, you know, bouncing around. We don't have any resolution at all for distant objects. Very difficult to see them. They just turn into blobs. And like headlights on a road. 2 headlights turn into just 1 headlight when they're far enough away. Are we seeing the headlights? Or are we seeing just crap? We're seeing light, but we're not seeing any detail. We're not seeing any structure. We're not seeing much. So the problem with the electrons are they're incredibly small. So just like a microscope has a huge limitation in terms of how small a thing it can see because everything's jiggling around too much and you can't see anything. It's just blobs. And the same problem would be with an electron. Even if you can bounce a photon off of it and get that 1 photon back, the 1 photon is such a tiny amount of energy, you can't resolve it anything. 1 photon isn't going to give you much resolution. It's just going to say dot. That's what 1 photon says to you, dot. Now, did you just see the electron because you got something back that says dot? I mean, yes, the electron's a dot, but that's not really representative of an electron because you get the same dot back if you sent 1 photon to a car. You know, you're getting a dot back, 1 electron. Yeah, it's not really a representation of the shape or the position or much else of the electron. And the idea that you could send multiple photons at an electron really can't work at all because the first photon you hit the electron with moved the electron. So now the electron, you've just changed its position by hitting it with a photon. So the second photon you hit it with, you're seeing it in a new position that you put it in. You're not seeing it in its natural state. So you just keep looking at your own distortions, the distortions you keep creating by hitting it with photons. So are you seeing it? So it's like if I take a time-lapse photo of me kicking a ball down the yard and I put all those photographs together, it's just going to look like crap. It's going to look like blurry crap. So am I seeing anything? No, I'm not really seeing anything. So I don't think you have debunked the statement that somebody said, you know, that we can't see electrons. We can't see them in any fair description of the word see. We're not really seeing them. Yes, electrons are what the photons are bouncing off of, but you can't call it see if you can't resolve anything. In my opinion, it's breaking the word see. Yeah, I'm done. Gee, that was quick. Fast. Yes, there's nothing added to the other mush show. So what else is there that I could mess with? Yes. The rational science guy did make a video with his son, and you know, it might be worth playing that if all else fails. I don't think there's any comments. No more comments. So maybe I could play that. Just really was testing this to see if it worked. Probably should see if it's still working. Yeah, that's me. I'm sort of in the box. The comments are up, so now I should be able to take those comments down, and by dropping that box, well, I don't really want to do that because I'll bring the YouTube thing back. But yeah, I can put the other thing on top with this, my writing. And then on top of that, I can move the drawing window forward. See, so this should work. Should be good. Yeah, I like it. So I just have to learn how to move which window where. So we are going to do video, so I can actually move the video up, which probably would be helpful. If the video even fits in the box now, because I have changed some things. So we'll see if the video fits in the box. We'll see. Yeah, the sound is a little tricky. It's funny that when I recorded with the OBS software, it kind of has some noise in the one microphone. I have to use the other microphone, but it's not quite as loud, so I have to fix that problem. And but somehow Google is able to access this microphone fairly well. Just just one of those things. It's just kind of irritating. How just kind of irritating. So here he was talking about his theory, saying what's the point. So I think eventually he's going to get to some lament about how no one pays any attention to all these videos. And these are very good conversations with his son, like I said. And everything really flawed about them is his counter theory is this idiotic idea that it's a pull universe and everything's got ropes on it and everything's pulling on ropes. And it's, to me, I can't make any sense of that making sense. That just doesn't sound right at all. So that's kind of a non-starter. The D. Hilster guy did make a video, but on electrons. But his argument is kind of lame in the sense that he's trying to say there's no such charge as an arbitrary concept. Clearly not. It's so pervasive in the function of everything. I just don't know how you say it's just arbitrary and it's not a real thing. It's obviously a real thing, and you got to account for it. And you're not going to account for it by just saying photons are a billion little photons and electrons are a zillion little photons, and it just doesn't go anywhere. Anyway, that's my critique anyway. So let's see if this shows up properly. Well, not exactly right? No, it's not exactly right. So let's change. I should just have to resize it. I wish Firefox would only resize the window you resize. It resizes all the windows, all the tabs. It really should just do the one tab. It shouldn't resize them all. Kind of annoying. All right, that should have fixed it. Yeah, that looks pretty close. Could be a little better, but close enough. That's what we'll say. Close enough. So I go here, and then I should just be able to hit the space bar. Let's see if that works.
Force, we don't need any time to explain how the farmer pulled on the donkey. We need a rope. We need a physical object, a physical mediator. And that's what physics is about, explaining how these things happen, how a magnet attracts another.
Right. And so he, like I said, he thinks pull makes sense when obviously push is so much easier force. So all you need to do is create a push force in the universe and concede that everything outside the push zone, everything inside of it, would be pushed by it. That means the galaxies and the stars and all the stuff out in the big universe would be pushed by it. All the stuff, all the little stuff would clearly be pushed up by it because it's inside the bowl or the bubble. And everything inside the atoms would be pushed by it because they're inside the bubble. I mean, solves the problem. Push is the obvious, in my opinion, answer. Just obvious. I just don't know how you can do this pull thing. What inside of an electron is pulling? What inside of a photon is pulling? I mean, it's just silly. Certainly no better than bent space as an answer.
What is the mechanism that compels a spoon to fall to the floor and not to the ceiling? That's physics, not all this mathematical nonsense that we see out there. Getting back now to your thing.
Yeah, just how you mentioned time was a perfect segue, perfect example of an assumption chain.
Okay.
But before I get to that, I just thought that these assumption chains are really deep because they go all the way to the dawn of human sentience.
Yeah, at least 4,000 years ago.
So they're talking about how they have one assumption and then somebody uses a theory based on an assumption or even an experiment. and uses that black box in his experiment. Now that has one assumption in it that could be right or wrong, like Benjamin Franklin picking plus or minus and getting it wrong. So there's an assumption. The assumption could be wrong, the axiom, and so you take that wrong assumption black box, put it in your experiment. Now you add another assumption, and so now you have your assumption plus his assumption, and then another person uses that in their experiment, and it has now the old assumption, this assumption plus your new assumptions, and yeah, you can put an awful lot of, you can hide an awful lot of error code that way, and anywhere in that mess, one flaw, and the whole thing breaks down.
We started looking at these things, you know, when we
No.
kind of gained the context.
Everything.
Okay.
Everyone builds on past knowledge.
Well, Newton said, "I stand on the shoulders of giants."
What is that? That's really important to know. And why we even read history and stuff.
Yeah, why don't we?
Yeah, why do you?
I like history. My son doesn't like history. I tell him he's got to read history.
Well, obviously we all have to learn it. So the fact that as a human race we're becoming more educated, but each individual also has to learn it. So, and there's so much now to know that none of us can really do that, right? I mean, nobody can be an expert at, you know, tree surgery and human surgery and veterinary surgery and car mechanic and test pilot, and we can't be everything. We can't know everything. So there's always a progression in terms of the learning, the amount of stuff you're going to learn. So obviously there's things you could spend your whole life trying to absorb information and you'd still fail because there's more information than you could ever possibly absorb already. So it's really about selecting what information is important. And that's about it.
So he doesn't repeat the same mistakes, but you're not talking about it.
Everything we know today, we didn't just come up with it out of nowhere. We got it from our previous generation. They got it from the previous generation. They got it from the
We memorize.
It's that, but we take what they give us and then we build upon it.
Okay, but we take it on face.
Yeah,
but we don't question it because we don't pass the test otherwise. No, because we don't pass the test.
It's not.
Yes, we learn from life experience, and that shortens the experience. Somebody else doing it for us, somebody else tripping on the step gives us the benefit of saying, I won't bother tripping on it, I'll fix it. So yes, we learn from the people in the past, but you can also be polluted by the information from the past, the wrong assumptions. Religion being a huge example of mental retardation that we're now experiencing, a kind of horrible, perversion of our rational skills from the past, the virus we still haven't cured ourselves of.
It's not specifically about school.
Then what is it
It's about everything that you know. Everything that you know was taught to you.
It's not there.
Yeah.
Everything you know. You go to the high school.
Grade school.
No.
Let's do it in the
Where do you get your knowledge? You get it
No,
from school or?
How to eat.
Well, whatever. This is a little bit of a strangled argument. I mean, clearly we haven't created enough technology or sufficient to see electrons. And again, maybe they just never can be seen. But we could certainly compile all the evidence that we have about electrons and then filter that evidence to make sure we don't have some wrong assumption about what electrons do. And even that's difficult to do because there's so many experiments and so many ways electrons can be used. But there's clearly that's the way that's going to point us to the right answer about what exactly the thing is that only certain models will fit all of that evidence. And I would argue the current model fails to fit all of that evidence.
How do you use the utensils, for example?
Okay.
It's hot. And forget school because that causes the issue. If you have utensils,
But isn't that
not
school?
use the utensils.
Mommy
That's
tells you?
the type of school. But when we say school, it's confusing because now we're talking about actual teachers and it changes the
Is
issue.
your mommy
I'm just trying to say
understand?
that everything that we know, we got it from past generations. So in a sense, everything is an assumption chain of theory, assumption, where you kind of build on what you were given. And it's hard to know whether what you were given was the correct. I mean, this is also talking more about philosophy, how to live.
Yeah.
What's the best way to live? That's also different than what is.
Okay.
Physics.
Yeah.
In that sense, that is
What
different.
exists, yeah.
But in a sense, they both stem everything that you.
The simple truth is that we've compiled a lot of information and we have conquered a lot of the physical world, flight and this and landing on the moon. And so we are fairly competent at manipulating and understanding a lot of this physical mechanism. But this little detailed part that's in this invisible world, this tiny universe, is a little tricky to do because you can't just look at it. You can't just watch it. You have to just watch what it does and then try to build a model that fits all of the doeses.
Assume today, when you want to brainstorm for why does magnetism work, right?
Yeah.
You have a very narrow pool of theories to work with. You don't have 100 theories.
No, you're right about that.
Because
maybe there's no more than 10.
Because there are, from the pool of assumption chains that you were kind of raised with, or that you just saw in your day-to-day, things that you kind of intuit, you kind of build this pool of assumptions, and they're kind of implicit assumptions going back to time, where you were trying to figure things out like the speed of light or gravity, and time kept coming up. And then only when you disregarded time as a faulty assumption did it make sense.
Yeah, because now you look at physics.
But that's why these assumption chains are very important.
Time got in the way.
It's important to keep in perspective that all our assumptions aren't just falling from the sky.
I guess assumption just doesn't really fit for what is accepted as, I mean, it's not a great way to describe, let's say Einstein made a mistake. I mean, obviously I'm arguing he made a mistake. I mean, it's just a mistake to think this bent medium of nothing is somehow manipulating planets and atoms and electrons, and that somehow it's changing their time dimension in some way, when time is just clearly the fact that the speed of light is slower than instantaneous, and that creates all kinds of room for things going slower than light, and slower and slower and slower. And the slower you go, the more time it takes. But time passes at a consistent rate, and light is a very reliable way to measure that consistency. You're not going to go back to the past because the past is gone, and you're not going to jump to the future because it's not here unless you freeze yourself. So dimensionalizing time is, do you call that an assumption, or do you call that a miscalculation? It shouldn't have been an assumption in the first place, you would almost say. It's supposed to be a deduction. And when it's such a weakly evidenced deduction, that is, there's so little real evidence of the fact of, it's almost like the ether theorists, there's no evidence of this ether, and yet they believe. Well, there's no evidence of the bent space either, yet people believe. Is that assumption? Is that delusion? I mean, if somebody believes in a God, and it just seems completely logical to say there's no evidence of its existence, it sounds like just a fish story told by human beings who are famous for telling fish stories. I mean, it's just obvious, just a story, just a fable, having nothing to do with reality. Is that a wrong assumption, or is that a colossal logical error? And certainly if it's done by somebody calling themselves a scientist, you'd say, well, shouldn't the scientist know that he should have sufficient evidence before he draws hard conclusions? So he shouldn't say something's a fact unless he has a volume of evidence. Just like people didn't say evolution was a fact. A lot of people believed in it. Darwin's grandfather thought evolution was the answer, but he didn't have a whole bunch of evidence compiled. So he couldn't just assert it as a fact. He couldn't just say, yeah, I'm really 100% confident. He had to wait until he had evidence to validate this. Yeah, it seems to fit. Everything sort of fits, but yeah, I can't explain this. And I can't explain that. And I don't know. And originally, when Darwin proposed his theory, the subject came up like, well, why are there no missing links? And it took us a good 100 years for somebody to figure out that, oh, we're thinking about it wrong. The evolution isn't happening in the giant herds, because in a giant herd, any deviation will be drowned out. If a wildebeest is born with 4 eyes, the 2-eyed wildebeest are going to replicate with him, and he's going to go back to having 2 eyes. The 4 eyes isn't going to win. It's less likely to win. It's going to get diluted. Where if it happens in a small tribe, then the 4 eyes becomes much more capable of diluting the 2-eyed wildebeest, and you have a much bigger chance of having evolution change. So that little logical argument fixes what seemed paradoxical and evidence against. So the absence of the missing link fossils said there's evidence against, but when you understood where evolution took place, which is in very small numbers of players, and you understand that it's very rare to get fossilized, and you understand that, yeah, it's very unlikely that 1/10,000th of the human population would get a fossil versus the huge normal humans. Yeah. Anyway, that was a long way to say it, but so again, I just don't know whether assumption is the right word in the context of where scientists should know better. So it's like the Eddington experiment. Scientists should know better to say, assert with such authority. They're confident photons are bent by gravity, yet their evidence is completely inconsistent. The galactic evidence has huge mathematical problems and creates all kinds of questions. Where's the lensing? Where's the lensing that should be taking place if the theory is true? Why are we only getting this tiny shred of Einstein ring? Why aren't we getting big blobs of light, we should be getting all kinds of refractions of light, and we're not getting any of those. Huge, huge problem. And then the Eddington experiment never being successfully repeated. I mean, that's one of your fundamental precepts of your science, is that you have to repeat the experiment. You can't just do it once and say, I got lucky and it worked out. And we know that Eddington didn't get lucky. That is, everything went wrong. So the results are even more suspect. And you only did it once. Yeah. A scientist should know we can't assert something based on that weak evidence. So it's worse than an assumption. Science shouldn't be making conclusive assumptions.
When someone makes full of assumptions to then build upon his theory, there's a whole history behind the assumptions people make. So when someone's, for example, you have this problem very often where they say, "Oh, there doesn't have to be a mediator between two objects for gravity." Like it just happens. Forget it. Like
magic.
Yeah, there doesn't have to be a rope or a bead or whatever.
All right, so they mock the idea because they just don't listen to anybody else's videos, which is sort of an irony. So he has a video called "What's the Point?" basically lamenting that no one's paying any attention, but he doesn't pay any attention. And he's not watching any of the other dissident videos. He's not paying any attention to the other arguments that are out there. And so they're mocking the idea of, oh, we need a mediator. Well, no, all you need is a force. And if you put it on the outside, it'll push everything together. That's what it'll do. Just like how everything looks like it's being pushed together. So it'll do exactly what everything looks like, which is it's being pushed into balls. That's exactly what an external force would do. But they're mocking that because they haven't paid any attention to it, which is really bad performance on their part. All right, we do have another comment, so we'll read that. Oh, message retracted. Yeah, I was going to read it. Now you retracted it. Well, whatever. Do as you will.
Or it just happens. Gravity just happens. So they have this pool of assumptions that they just kind of take for granted. It's that taking for granted part that kind of irks me, because that's also where teaching goes south. Like when you try to teach me something and there are implicit assumptions or biases that you have that I don't have, it's very hard to teach. It's hard. You can't skip that. You can't skip that step. You got to cover that step. I think I got to be on the same page. Yeah. You can't start teaching if I don't even know how to add. Kind of.
Well, that's a bad example, because then you're saying that you somehow don't understand because you haven't been versed in the idea of a virtual photon. So that's the cop-out they use. Oh, you just don't understand. Virtual photon is a good answer. No, if you really explore it, it doesn't mean anything. They're just saying there's a virtual photon because there's something happening, obviously, and something must be causing it, so we just call it a virtual photon. But they have no idea how it actually makes anything happen. So they're just using it as oh yeah, the virtual photon did it. Don't pay attention to exactly how it does it. It does it, though. So it's not a lack of knowledge that makes the virtual photon an empty answer. It's the fact that it has absolutely no model for its function. Virtual photon doesn't actually explain anything. It doesn't go anywhere. It doesn't do anything. The virtual photon leaves the magnet, and that's the end of their explanation. Well, yeah, it leaves, and something happens. Something. So again, we have to go back to why are these assumptions conclusions? So this should be the key point, is none of us should be making assertive statements as if this has to be the truth when all you have is weak evidence. And that's what physics does all over the place. They teach the subject as if they've proven something when they haven't come close to the burden of proof. Not even close. So it's like they're setting up a bunch of false accusations against a person. So a person has a fight with their girlfriend, and now they change the story. He's a wife beater, and he's this, and he was caught taking a piss on the street or something. And they start adding up a bunch of circumstances that all have explanations, and they just don't care. Okay, because it's a little bit of evidence. Now we can slander the thing and create a story that somehow he's an evil person, when none of that ever happened.
Yeah, you gotta go in steps.
You gotta go in steps. So there are certain, I mean, this is the biggest problem you have when you're just trying to get people to understand, forget confronting or anything, just trying to get someone to understand one theory. You have to kind of bombard them with so many assumptions that they don't already hold, that it takes years for them to finally get that moment, like, oh, now I get why Bill uses object, shape as object, the location is this.
Yeah, because it all is comprehensive.
But it's like this web.
You know, well, there should be some evidence. And again, there's logical evidence to why rope theory. You ask a question like, well, how do the ropes not get tangled? He doesn't have an explanation. Who's pulling on the ropes? Where's the energy for the pulling? I don't know. You know, they're just not answers.
You can't just take one definition out of context and take it on for it to make sense. You have to take the whole thing, and for that, it's.
Let me ask you something. Come over here. I want you to show your face here. I'm not talking to God, just in case. You know, we have my youngest son here. He's the guy on the other side. Okay, just just so you know that I'm not talking to the wind here. You know, it's kind of scary. You know, when you hear this voice out there in the wilderness. Okay.
Yes. Well, his son should actually make videos, and maybe he could make response videos, and maybe you should get into a conversation with somebody besides just you to explore the possibility that there are alternative theories that do provide have an awful lot of explanatory power, and you seem to be in such a niche that you aren't paying any attention to that possibility, and that you're expecting people to pay attention to you. So you pay no attention to people exactly in the same position that you're in, and yet you expect people to pay attention to you. Now, that's a little bit duplicitous. I mean, the fact is I watch a lot of other people's videos because I'm saying maybe they want to say something brilliant. Unfortunately, I'm mostly disappointed. But I do give them credit when they make some argument about conventional physics and point out that, yes, this is a flawed theory, and we should replace it with a solid one that has evidence, not another one with no evidence. If you're going to replace it with something that has evidence, not something that doesn't have evidence.
So
I'm just trying to show the importance of assumptions, of the origin of assumptions.
Yeah, sometimes, you know, and that is true. You know, sometimes you take some things at face value. What do we mean by that? When you're taking face value means that you accept it or you believed, you know, because you're using your theory, you believe the assumption, the theory of someone else. Someone else had an assumption. He came up with a theory. You take the theory, his conclusions, his results. And you say,
yeah. But that has more to do with the fact that they can say something that is superficially sensible. So when I just make the simple statement that an external force, the universe looks like what a universe with an external force would look like. Everything clumping into spheres. That's exactly what an external force from all directions would create. It's a bunch of balls getting closer and closer to each other. So, you know, people could say, yes, now that looks good. And they could be saying, that makes sense. But they do have to go deeper because it does have to explain the drag problem or this problem or that problem. It has to explain why do magnets do this and why when you turn them upside down do they do that and why. So there's more details that you have to go through. And clearly just the external force, right, as I've already been pointing out in all these videos, that's what I started with. And it wasn't good enough because when I got to magnetism, I couldn't make any sense out of it. I couldn't make the external force do attraction and repulsion. And it wasn't until I realized the external force is itself charged. It's made of two elements, just like the matter. It wasn't until I did that I made the external force be able to do magnetism. We do have a comment, so I might as well read it, but it's about CERN, which is not terribly fascinating. So Gary, just curious, what do you think of CERN? I think it's insanely expensive. I'm not saying particle accelerators, we've learned things from them, but they're a crude tool. And the whole idea of looking at things based on how they plow through snow. I mean, they say there's a positron. They say it because a proton went through, well, the positron went through a 1/4 inch of lead, and then it plowed through a cloud chamber, which is basically plowed through a bunch of snow or something, a medium, a bunch of atoms. It created ions. The ions created the pattern you see. So it's losing energy through all these processes. It's certainly going to lose some energy plowing through lead. It's likely to hit something. And it's certainly hitting something when it's creating the image in the cloud chamber. It's hitting something. It's not a photograph of what it does naturally. It's a photograph of it plowing through snow. And the argument can just be made that when it's plowing through snow, it's going to more rapidly lose its velocity, and certain things will change. So anyway, but they've deduced it can't possibly be a proton because somehow it's going too fast by their standards. But what if one of those standards, those assumptions are wrong? If their assumptions about how the thing functions are wrong, then of course it could be just that it's a slower moving proton or a faster moving proton. It's moving faster than they think it should after it went through lead and plowed through snow. But there's reasons to believe that every time something goes through, it can hit more stuff or less stuff. So there should be variable results. Every proton shouldn't come out of the lead exactly at the same speed. It would be kind of silly for us to have that expectation, wouldn't it? All right, so anyway. I'm just saying it's very thin evidence for the conclusions drawn. So CERN has drawn all kinds of hard conclusions about the existence of quarks and positrons and antiparticles, all kinds of crap. And all of those conclusions are on evidence that's just that thin. Little bits of reasoning about, well, I've never seen one do that, and why is it doing that different thing? And and they draw deductions, but it's a tiny amount of real evidence, tiny, minuscule, and they are so confident that their imagination, their immediate deductions, their first impressions are the truth and the whole truth and nothing but the truth. No, they're very short of that. This is a very superficial investigation. It's like a detective going to a crime scene, just going, oh, there's a gun, a dead chick, guy hanging over there. Yeah, he killed her, hung himself. Okay, done. When, yes, the story could be much more complicated. There would be all kinds of DNA of the psychotic killer who tortured the husband and raped the wife. It's just, CERN is casual science, not serious science. Okay. Extremely limited experimental conditions. I don't know what that exactly means, but it's very difficult. The stuff they're trying to do is like, look, it's like the idiot's exaggerating and saying we photographed an electron traveling through space. I'm just saying theoretically we know you can't do that. There's no theoretical way because there's no energy you can hit an electron with that doesn't affect the electron's motion. So you've violently interacted trying to measure, trying to photograph. You cannot passively photograph an electron. It's theoretically impossible. There's no theory to justify the capacity to do it, and yet they're claiming they've done it. That's how bad it is. All right, makes sense. Please share your opinion on saddle-shaped universe. No, I'm not going to bother with that. I never heard of it before tonight. Well, I don't see any point in me worrying about what shape the universe is. I think it's just a complete waste of time. That's another zone you're going to have no access for. You're never going to create a wide enough perspective to know what the hell is happening in the universe in any real sense. And frankly, I just couldn't give a rat's ass. It's so distant from understanding the physics. The small universe is really the only universe. The big universe is just an emergent property of the small universe. So in my opinion, understanding the small universe is 99% of the game. Figuring out what the residue on the outside is doing, not terribly interesting, in my opinion. All right, so that's it for that. So back to the videotape. So click on the bar, not the video, and the space bar should still work. No. It's just so funny. So I have to hit P and then the
I'm going to
space
accept
bar.
them as a fact. And I'm going to use them as my starting point. That's going to be now my foundation, and now I'm going to build upon it. You know, like Newton said, I stand on the shoulders of giants. And
So he said that twice. He says it in a lot of videos. I don't think it's a very interesting quote to make. You stand on the shoulders of errors, mistakes, fools who jump off of cliffs with feathers tied on their arms. That wasn't a giant, but in a sense, we all stand on his shoulders because, I was going to try that, and he's done us the favor of being an idiot for me. So to call it all giantism is kind of silly, because most of it isn't giants. I'm not a giant. Let's say I'm right. Imagine just for the sake of possibility that I am actually correct. I really wasn't a giant. I just happened to be enough of a cynic, and I got a bug up my ass over it when I was a little kid because I hated this stupid wavy shit that they were saying photons were doing. I couldn't understand how even snakes can't do it, and the photons doing this snaking in both directions. It just seemed fucking idiotic, and I never got over that. So does that make me a giant? No, it doesn't.
oh, now you build upon it. But it turns out we do this over and over from generation to generation. And at some point, there's a generation out there, us maybe, we're 400 years later from Newton and some of the Galileo and all these people. And we say,
like say even Newton, a kind of a giant, but frail, in the sense he believed in angels. I mean, he was he had elements of his perception that seems retarded. He was like an idiot savant. You could even say Tesla. Tesla did really well when it came to doing one thing, this whole idea of phasing electricity. But he sucked at understanding anything else.
Where did all this come from? Where did we get the wave? I looked up a wave, a long time ago now. And, I said, okay, 19th century, this was famous. Everybody just believed in the wave version of light. And it turns out that if you take it before the 19th century, before 1800s, it was Newton who roared the particle. And by particle, they meant corpuscle. Little ball.
Yeah, well, to say it was Newton who roared, but the truth is that Huygens was winning the argument with a lot of people. And Huygens was strictly waves. So it really wasn't that clear even then. It wasn't decisive in any way. And it's just kind of tragic, in my opinion, that yes, it all went wavical.
Tiny ball, that's what they meant by particle. That's important. And so they dealt with a particle for 100 plus years. Then 19th century, they went into the wave. You had started really early at the century with Thomas Young, and he did his slit experiment. He said this can only be explained with waves. Then we had Augustin Fresnel, the French guy, and he came up and he looked at polarization.
Well, like I said, all of that is a kind of a poor context, just because that just shows how poor the science was in the 1800s, in the sense that they apparently had forgotten everything Newton had done. Because Newton had already demonstrated this effect of light being diffracted by a small opening.
He looked at also the slit experiment. He explained it in terms of the waves. He kept going with Faraday and eventually with people like Maxwell and Hertz and so on. And they all said, light is some kind of wave, transverse wave to be more precise. They abandoned.
They all believed in an ether, so that's sort of the important part. So they thought of a wave because they thought there was an ocean, some medium sloshing around in the universe that everything was just bouncing in.
Huygens, Christian Huygens, he was a guy from Netherlands and also contemporary of Newton, and they abandoned his notion of a wave, where he explained water waves. He says, you have a point source that explodes and turns into all these little vibrations, and each one is a point source of secondary waves and so on down the line. And they said, well, light does not really work that way. It's more like a transverse wave, and that's what James Maxwell described, mathematically. Well, that lasted until the 19th century when we had Mr. Planck, Max Planck. He came up and he said, when I do the black body radiation experiment, I have to consider that light comes in discrete packages. And people said, how can that possibly be? Light is continuous. Well, he said, yeah, I think so, because remember, Max Planck did not believe in his own theory. He said, this is what I present. This is the math behind it that describes it.
Yeah, well, I mean, it's saying that the evidence is clear that waves have this sine thing to them. That means they get stronger and weaker and stronger and weaker. And all the evidence just points to the fact that photons, there's not a half a photon or a quarter of a photon or any of that stuff. There's a photon, period. And all you can do is increase the amount of it in a certain amount of time. But it's clearly a quanta of energy. It's a samey thing moving the same speed of light. It doesn't move some other speed, so it can't change its momentum. So waves create things that have variable momentum, where clumps don't vary their momentum. And that's clear that photons don't vary their momentum. Just shouldn't be an arguable point.
But I don't accept the physical interpretation that, light comes in discrete packages. Well, that's when, by the time they got to the Solid Conference, Fifth Solid Conference in 1927, they finally said, look, you guys believe in the wave, we believe in the particle, let's do something. Let's reach a consensus, let's shake hands, and we'll make it a wave particle. Particle wave, wave packet, whatever you want to call it, and we'll merge them both together. And Mr. Niels Bohr says, I'll come with a complementarity principle, which means that for these experiments, you can use a wave, and for these others, you can use a particle. Whenever you can't explain it with particles, just use a wave. Whenever you can't explain it with waves, use a particle, and so on.
That's like if at a soccer game, we have two referees, one referee for your team, one referee for my team.
Yeah, you can't explain it, so you reach a consensus. Well, science doesn't work by consensus. Unfortunately, science doesn't work by consensus.
Well, consensus is different than compromise, so that's kind of the wrong word to use. So science shouldn't work by compromise. You don't compromise with errors. You don't compromise with lowest common denominator idiots in our politics. We shouldn't be compromising. Compromise is stupid. If you have any idea of principles being preserved, or it's like compromising as an artist, well, then your art will be shit if you compromise with something called noise. So if I compromise, yes, even with a signal I'm sending or a photograph, oh, let's make a compromise with noise. So noise is competing with the photons from the image. And so instead of eliminating the noise, let's compromise with the noise. Well, then the photograph's going to suck. So compromise is really dangerous in physics, but just as dangerous is saying, I'm going to take two low evidence theories and choose one. That's also dangerous. I would argue the particle theory of light is high evidence versus the wave wackiness.
I don't care about science, but Mother Nature sure does.
I hope Mother Nature doesn't say, well, I think I'm going to convert the particle into the corpuscle into a wave just to explain the slit experiment, then I got to convert it back to a particle to explain Compton's experiment, and I got to change it back to a wave to explain, I don't know, or to a particle to explain the photoelectric effect, and then back to the wave to explain polarization. Mother Nature, you drive her nuts if you could convert particles into waves. And when you look at the particle, it's not the corpuscle that Newton talked about. Corpuscle is a particle is really it's a field. Yeah, it's a field. And where's a field? You look at the word field, and it's a.
So we're just back to the ether, as I pointed out. Obviously, you have to have a field or an ether or a medium for waves to be a reasonable kind of thought. But they're still unreasonable if you have a wave that is a straight line. Then you're breaking the concept of waves, because waves don't do straight lines. So the whole subject should just be over, because you can't use the word wave to describe something that aren't waves. And a laser beam obviously doesn't illustrate a wave very well. So it's just broken language in so many ways, and it's just steeped in this. Again, the ether. People who just don't even want to admit they believe in ether, so they call the ether bent space. Bent space is now an ether. It's something you can bend, and creating these fields that don't have anything in them, that don't have any evidence that they even exist, like the electric field. No evidence that any such field exists. You can't watch something get bent by this field. It doesn't exist. There's no evidence of it, and yet they keep saying it's there. The electric field. Where is it? Every time I see electricity move, I see it going through a bunch of atoms. I see it moving through atoms. I don't see it moving through any field. Where's this field?
Undefined word, there's all the words in mathematics. They're all undefined, and when they relate to, when they try to give physical interpretations, and the most important word that's undefined is the word field. It's just, you can think of it as a spider's web that extends throughout the universe. That's the field. Yeah, but think of it in three.
Yeah. So again, so here he's going to ridicule the field and call it a spider's web, which is silly. It's a liquid or something. It's something the stuff perpetuates through. And he describes it as a spider web, which is the same thing as this silly rope crap, you know. So you can't mock spider webs if you're going to use ropes as your argument. I would mock both. It's just insanely unnecessary. What do you need a medium for? Just use torpedoes. You know, I don't need a medium. I mean, you know, torpedoes in the sense of rockets or, you know, anything, bullets. Just use bullets. But what do I need a medium to make my bullet go somewhere? No, I'll just shoot the bullet. What do I need the medium for?
I mentioned I'm not like a flat, you know, two-dimensional spider's web, but think of it in three-dimensional radially. And the three-dimensional spider's web goes to the edge of space-time, I guess. I don't know. So it's a bunch of values that surround an object. That's what it is. Whether you're talking about gravity, you're talking about the field for an electron, whether you're talking about the field.
See, the idea of reducing geometric space into locations and then giving those locations a product of effects, that is, we could locate me, and then we could say, yes, there's a desk next to me that has a certain mass, so it's affecting me a little bit gravitationally. I have a glass of drink over here, and that's affecting me. There's other things affecting me, and so there's a value made or created by all the magnetic and gravitational stuff around me is affecting this location with a certain amount of energy potential. And so that makes perfectly rational sense as a way of viewing it, that every location in space is a location where a certain amount of pressure is being mediated by things in the way. So there's stuff around me that's blocking and deflecting pressure. And so the pressure that actually hits me is decided by these things around me. So that makes sense. But to say you need a field to do that is idiotic. There's no field that number exists in. It just exists in locations in space. And the force is what's affecting me. The thing that gets changed is the force. The planet absorbs the force. It doesn't get to me. There's a real force. My hand blocks light. It's a real force event. The matter blocks the force of the light. The light can't get to me. There's no field involved. There's no need for one to explain what's happening.
Of a pion, of a muon, it doesn't matter. It's a radial region of values, of magnitudes, of units. That's what it's a mathematical concept. So you say, hold it. You're saying that this field went through the slit. How did it get all these, you know, these spider web, the web, you know, went through the little slit. And so, so it doesn't end in a rational physical interpretation. They convert the particle into a field. They say that's what went through the slit. You say that doesn't make any sense. Of course it doesn't. We don't understand quantum mechanics. That's the answer they give you.
Well, that's what we end up with the faulty assumption chain.
Well, they say they don't understand their own theory. And that's like saying that, yes, no, we don't understand how space is bent. We just say it's bent. We just say we don't understand how every little tiny thing in the universe is somehow pulling space into it. It just does. And the virtual photon for magnetism. Yeah, well, we have an explanation for magnetism, the virtual photon, but yes, we don't really have any explanation for how that virtual photon actually makes the magnets move. So yes, it's just terribly weak as theory. It's just terribly thin. You scratch at a little tiny bit, you ask a few questions, and it just falls apart.
So what we're kind of saying is kind of to question everything, question your assumptions. I mean, a good point to make is that what we believe are basically assumptions that we take for granted. Yeah. Just any implicit assumptions that you make, we're going to call those beliefs. At least I may call that belief. Belief to me, the definition of belief is an assumption that you take for granted. That you don't.
No, hold on. Let's clarify that. An assumption is what you take for granted.
No, belief is just about what you've concluded because you have to. Sometimes we have to choose the left road or the right road. We have to. We have no choice. We're given an option. We're saying we have to get somewhere. We're going. And we're going to choose to turn left, or we're going to choose to turn right because we have to choose because we can't stay here because we'll starve to death. So we have to make choices. Other choices we don't have to make. There's no urgency to draw conclusions here about physics, but they feel an urgency. I got to be first, and I got to do it first, and I got to make up this story first, and I got to solve the problem first, and I got to blah, blah, blah. And so they seemed very urgent, and part of that urgency has created these mistakes because they want to get to the next level. They want to get to the next level. So they're sort of cheating each level a little bit because they want to get to the next level of physics. They want to get to the next level of physics. So they're running up the stairs, and they're making a mess of it. They've tripped all over the place, and they just don't know it. You know?
Means that you actually turn it into a fact. Belief means now you're going to believe.
It's not you're saying when you give a presentation.
Yeah, okay.
All the assumptions that you make without stating them as such. For example,
Oh, but then it's a fact. But then it's a fact.
Yeah, but it's really a belief.
I mean, we are stuck. Particle, wave. There's really, those are the only two choices that have any viability in this contest about what a photon is. So, yeah, you're sort of stuck saying, okay, yeah, I already got to pick one or I got to pick the other. You know. So, but you can just do it in the sense of, but I'm not sure, I'm not confident. Give me some more evidence, please. You know, make it a better choice. Make it so I can understand what's better, the chocolate cupcake or the frosting on the brownie. You know, which one is better for me? Which one's healthier? Which one will I live longer if I eat? Yeah, it's just hard to tell because they sort of look the same, like the same gooey mess. And what I really need is an apple. You know, that's what I really want, is something good.
Yeah, but what does belief mean?
If someone gives a presentation and they explain magnetism, why these two magnets attract each other. Yeah, he's doing it on Earth. He's trying to explain an observation that he did on Earth, right?
There it is.
Right there. There's gravity on Earth. Yeah. It has nothing to do with the explanation, but it might.
Yeah, so pushing two magnets together doesn't explain it. And again, his rope theory is crazy. His explanation of magnetism is all this swirly stuff. So there's a bunch of swirly ropey stuff spinning around, and then those ropes are like jump ropes, and they're going this way, and the jump ropes hit each other. You know, one jump rope's going this way, the one jump rope, and so they hit each other, and that's somehow pushing the magnets away. And then if they're going together, it's somehow pushing the magnets together or something. Just, well, it's actually the other way around. Somehow the hitting ropes are pulling together, and the ones going the same way are somehow pushing away. Which, again, just, I find that a hopeless explanation.
So he's not invoking gravity per se to explain it, but he is implicitly. There is gravity in the gravity could have something to do with it. Let's put it that way.
Okay, good. Yeah.
So this is important in sort of just saying this gravity could have something to do with it, because people really don't think about the fact that gravity is in all directions. They just think about it like, oh, gravity's going this way, and that's gravity. No, gravity is going in. Gravity can be anywhere. I can put something big right next to me here, and now I can have gravity this way too. So I can have gravity going this way, and I can have gravity going this way. I can have gravity going lots of ways at the same time. So it's perfectly sensible to understand that, oh, two magnets in space can be pushed together because there is gravity there, and all they have to do is be objects that sense the gravity more than, you know, non-magnetic objects. So if they can sense the gravity, if I make these two things sense gravity more, I can make them smash into each other at any angle. No matter how I place them, they will do exactly the same thing, move together. They don't have to be in line with this gravity.
It's in the gravitational field. We're trying to explain magnetism. I mean, as far as common sense goes, gravity has nothing to do with it, but all I'm trying to say is that he's implicitly...
So he just says, as far as common sense goes, gravity has nothing to do with it. But that's common ignorance, right? Because if you understood that gravity is a force, you have to understand that that force is going through everything all the time, place everywhere, and that clearly it could have something to do with it. It's a force. And all you have to do is be more sensitive to it and call it a magnet.
Invoking gravity. So gravity is more like a belief. It's like we don't have to talk about that. Everything that he doesn't explicitly state, okay, we're going to assume I have two pieces of metal, we're going to assume they pull each other. You just do all the assumptions, but there's a shitload of assumptions that you make that you don't state out loud. Like the color of the
metal. Maybe not gravity, but you might make some other assumptions.
Yeah. Kind of like, it's kind of in the realm of belief.
Well, again, it really isn't about assumptions. It's just about incredibly weak amount of documentation for the choice you're making. So it's like health food or something. I don't know what examples to give, but you're given almost zero information about the quality of the two choices you're given, two kind of muffins. And you're given no information really about how much sugar's in them or fat calories from Greece or nothing. Very little information, and you're, making a choice. And that's where the problem is. This is very weak evidence theories. Theories based on shreds of evidence, not volumes of evidence. And that's why there's such an implicit failure written all over it.
Beliefs. Where it's like
you take for granted some things like, oh, you know, right?
Yeah,
it's like,
that's what I'm talking about. It's like, oh, that's a belief you have that I don't. So you do have to explicitly state that.
Until someone challenges you, and now you have to explain, what do you mean? You didn't go to high school? You didn't go to college? No, I didn't. Please explain.
Yeah, see, our certainty can be totally justified times and then totally unjustified. So yes, 2 + 2 = 4. You can be quite certain about it because it's been tested so many ways. It's just rock solid that 2-ness plus 2-ness equals 4-ness. It just is, and the labels fit, and the labels were created to exactly describe what these things are doing, and so it's rock solid, like me saying water's wet or something. So you can be confident about, can't be wrong because the word was invented to describe exactly what water is, so it can't be wrong. And then there's circumstances where the answer isn't obvious, and it isn't solid, and it isn't been well tested. And for scientists not to be able to make those distinctions and admit when they're drawing conclusions based on weak evidence. So in the case of like evolution versus God theory, you can say there is a huge volume of information, knowledge, information, facts, and all of them point to evolution. Not just a majority, all of them. And none of them point to creator. Not a single fingerprint of a God, not a single electron out of position because God did it. So no evidence for one thing, volumes of evidence for the other thing. Now the silly people ignore the evidence and say, I want this truth to be true. Mommy says so. But a scientist, should ignore the volume of evidence and jump to the silly conclusion. So again, I would argue that you pull people are missing something obvious, that pulls are inverted pushes. So look for pushes. This push is what the universe is made out of, not made out of no pull.
Please explain exactly.
The answer is no, I haven't. Please explain.
If two mathematical physicists were explaining, or one were to explain something to the other, they both had the same
background.
So there's a list of things of assumptions that they wouldn't have to explicitly state because they both got that physics 101, 102, 201, all that. It's like there's a lot of things that they can do shorthand with.
Yeah.
And those are more like beliefs. Like, okay, we're both on the same page on that. Let's try to build upon that.
A very case in point, time dilation. What do you mean time dilation?
Well, so yes, there's this huge confirmation bias where they all confirm each other's. You smell good, I smell good. They just confirm each other's bullshit. So there's a huge problem with that.
Time is not a physical object. Well, you don't understand the term time dilation. That means something else. And it's a code. Within the mathematical community, they say time dilation. That's the shorthand for a whole bunch of other stuff that has nothing to do with bending time.
Right. And again, they'll say something like time dilation as if they're talking about some sort of dimension dilating or moving or warping, when all it really means is time retardation. That is, you can retard the function of things by giving them velocity. You can change their function, and if it's a clock, the function change will be it won't tell the right time. And that's all it is. That's all the evidence points to. That's all they have evidence for, is that things tell different time when you move them. That's all there's evidence for. All the rest of the story is made out of no evidence.
What do? You bend a second, you bend a minute, you bend a year. What is it that you bend over there at the mathematical club? And they say, well, you don't understand. You haven't taken mathematics, 202 or 101 or 302 or whatever. And you haven't taken advanced mathematics. That's why you don't understand, because time dilation is something else.
You're not on the same page.
Right. And so the issue is they use all these code words, these code phrases. We transfer energy. We move the mass. We carry the force. And they understand it. And you say, well, hold it. What do you mean you carry the force? You move the mass, you transfer energy.
The problem with that is there is this implicit assumption problem where since they both believe they don't have to explain that to each other, they don't.
So again, this really isn't a problem of assumption. It's a problem of conclusion with insufficient evidence, weak evidence, hard conclusion, fundamental mistake.
Visit the copy, so it stays underbound. It stays all the problems with it.
Yeah.
the
hidden
unspoken,
variables.
all the hidden, problems with the assumption kind of go unpunished.
Yeah.
Because they both kind of go, you know what I mean?
Yeah, and that's next.
I mean, it's not weakling that because it's kind of like, okay, we both took that class, we don't have to talk about it, let's just build upon it, even though we don't really understand it. If some third person came in, some layman, and asked, hey, he starts asking all the quote-unquote dumb questions, and then they start rolling their eyes like, oh man, you just have to roll over these questions. Don't look at the details.
Yeah, don't take them literally.
Yeah, don't take them literally.
Yeah, you're not supposed to take them literally.
They want the implicit assumptions that hurt to stay implicit.
Yeah.
A lot of words saying nothing there. I mean, yes, but just say confirmation bias. Confirmation bias. They're all saying yes. It's emperors wearing no clothes, but it's probably more than that in the sense that the religious folks often don't need to have other people confirm. They like the fact that we're the majority and all that stuff that makes them feel more secure. So they want other people to be just as stupid as them. But the stupidity is built into the argument. I mean, the religion is on its face a fable, a story, a fairy tale. The fact that humans have been compulsive liars throughout their whole history, and that this is, no reason to believe any of these events are historical facts in this book, is glaring. And the fact that it certainly wasn't written by some perfect God. So whoever he was talking to write his book, the translation was really poor. And you'd think an all-powerful God would make sure his book was understood by everybody. So, I mean, the logical arguments are just glaring. I mean, the fact that the existence of a God does not answer the question of, why is there something? Obviously, you have to ask the same question to, why is there God? Where did he come from?
They don't want to make those explicit because now you can actually look at them.
So where do we conclude as far as assumptions then?
About that, an interesting conclusion or a question more that I want to ask is, because the moral that we're kind of going around is to question yourself.
So they're arguing about assumptions, and I would argue that the real subject is conclusions based on weak evidence. Hard conclusions, weak evidence. That's mushy evidence, you could say. Hard conclusions, mushy evidence. They have, in the wrong order, they have cart way ahead of horses. They have jumped the evidence. Those would be my cliches to say that's the problem. Assumption is part of that, but the motivator that's making this happen, why this cart's getting ahead, why are they jumping so far ahead of the evidence? Why are they seeing weak evidence as strong evidence? I would have to argue it's the same reason people believe in gods that are preposterous stories, preposterously improbable to be the truth, that are so easily logically argued to be nonsense. Who's the real savior? Muhammad, Jesus, Buddha, blah, blah, blah. I mean, none of them have any more credibility than the other, and people believe it because their mommy did. That's not a rational answer for why you believe something, because mommy did. I mean, it's ludicrous. And so the real argument is, as you can see, that humans are glaringly disinterested in the truth when it comes to things like religion. They have no ideal that the truth matters. A lie is just as good. And physicists are just demonstrating that they're just as frail as the imbeciles, that for all their technical knowledge, they haven't figured out how to have integrity, or they haven't figured out what those kind of words mean, to have intellectual integrity, to keep their intelligence clean and reliable and useful. They've allowed it to be just as manipulated by what they want to be true as the silly religious kook.
To question your beliefs, question, for example,
more than your theories.
Just question, like, just whenever you're thinking about time, question, okay, what is time?
And especially,
I mean, they're saying, instead of saying mommy says, the physicist, they're saying, oh, my Lord Feynman said, my Lord Rutherford said, my Lord Tesla said. It's just as bad. It's just as big a crime against their intelligence. And they're doing it. So their intelligence has made they're smart enough to know how not to be an idiot. Not being an idiot isn't part of their knowledge base.
Let me clarify. Especially when you don't understand. I mean, you don't just nod. You say, excuse me, could you clarify that?
Or just
I'm too stupid to understand this.
Or just, could you clarify? I'm talking more to myself.
Yeah.
If I'm just in a room by myself, I'm trying to figure something out, then you're kind of forced to look at the implicit assumptions because there's some assumption that you have that's not making this, that isn't right.
Because you don't understand the theory, because you didn't understand the assumptions to start out.
Exactly. So the pieces don't fit, so some pieces off. Is off. Which one is it? Then you go one by one. But then the question becomes, which is a very deep question, you can't underestimate it because it's one of the fundamental questions, which is where do you draw the line on what to question?
Yeah. And
for example, you don't question that there has to be a mediator between two objects to explain action at a distance.
I know, but a lot of people do.
Well, whatever. I would question any such need for a medium ever. But regardless, bullets always work.
And it blows my mind when people say, why do you need a mediator? And I'm saying, you mean this particle affects this one at a distance, gravitationally, electromagnetically, any way you want. And you're saying this one affects this one at a distance. They call it entanglement in quantum, and there's no physical mediator?
Well, again, the fact is we have no evidence that this is really happening. And clearly you could break the rules anytime you want to by just inventing something that's going so fast that we can't possibly ever detect it. So you could say there's some superluminal c² particle, and theoretically it'd be very hard for us to detect. So you can make it out of something black hole. You can make it out of non-real matter. Matter that only does the speed of light. It doesn't do any other matter things. So you don't need a medium. You just need some fake, phony mechanism.
You do it then with spirits? I mean, what are we going to introduce in that space? Think about that.
But then the question you didn't answer yet, or just running of listening, is where do you draw the line on what to question? Because you do question some things.
Well, I think some things are more than common sense. I would put them above commonsensical. It's like,
I mean, c², right? If you could actually do it, preposterously, insanely high number. You might as well call it instantaneous. So I'm just saying you could just do that. You could just square the speed of light. You'd create something that would be instantaneous. I mean, it'd go from one side of the universe to the other side of the universe in some kind of billionth of a second.
I don't have a word to describe it. It's like you're born with it. It's like no one had to teach me in my entire life. I didn't have to go to school for this. I was born with it. I can say that between two parties, this particle affects that one. If the farmer pulls on the donkey, if the magnet pulls on the magnet. I don't know.
No one had to teach you. Of course, you had to learn everything you know about up and down. You had to learn what gravity was. You had to learn everything. So it's just silly to say no one had to teach you. You did have to learn some mechanical rules of life that you don't, gravity doesn't make you fall up. You learn that. You don't fall up the stairs. Well, you can. When you're drunk, you can do that. I've done that. But anyway, continuing.
There's a physical mediator in there. It's like, for me, it's a non-issue. And there are people who say, well, why do you need a mediator? Why do you need to put an object in there? And it just blows my mind. So what are you doing physics with? How do you think a magnet pulls on another? With magic? With spirits? With God?
So again, he just doesn't pay attention to the fact that there's lots of explanations, and even conventional physics, although they don't have a complete answer, they do have kind of an answer, that the information is conveyed through these virtual photons and, the force, the field, the whatever. So they have some mechanism that's just as real as the mechanisms they have for some other stuff, which I'd say is also nonsense. So I'm saying your critique of regular physics is fine. Their answer sucks. But to imply that no one else can answer the question with something a lot better than a silly rope. If I'm trying to move a donkey, the only way to move the donkey isn't a rope. Okay, I can throw a firecracker behind him. I moved him.
What are you going to put in? We can do magnets.
Nothing.
Nothing?
We're just going to keep it unanswered.
I mean, here we go. This guy pulls on that one. I can't even break him apart. It's like, and there it sticks. And it doesn't, I can always feel it pulling here, And, here I'm trying to put them together. And
yes, just like gravity pulling. So when they're pulling, it looks just like gravity. And the part that's a little tricky is the repulsion, because it's not like gravity. But if you understand what's causing the pulling, then you can understand why it's not like gravity. But it is gravity. It's a pressure, little ping pong balls bouncing back and forth. You can't move that in. You have to move that out.
Yeah, let's go past each.
That's why the question.
And I'm saying, hold it, there's nothing in between there?
But that's why,
What is it? Spirits, God, angels? What are we gonna put in there? Energy, mass? What do you want to put in there?
that's why the
Force?
question is. That's why the question then is, where do you draw the line on what to question?
Yes, the very force that forces electrons to repel each other. So I could argue your rope theory. How does rope theory make electrons move away from each other? How do they push on the rope?
You question some things, but there are some beliefs or assumptions that you kind of say, okay, I'm not going to touch these.
Yeah, but you know what I do? What I do is divide people into scientists, rational people, and irrational religious people. And I'm saying it's a religious person who believes that two magnets are attracted to each other or repulse each other without a physical medium.
Look, the other point here is closed minds don't help. And I would argue you people just demonstrate a very closed mind. You're just as closed mind as conventional physics. You keep saying things with this authority as if you have inspected the possible other explanations. So conventional physics says, we've already debunked all of this. None of this could possibly be true. And you're just doing the same thing as if you've done any of that when you haven't done any of that.
These people simply weren't born with common sense.
Yeah, but that's just that one. For example, time.
I'm the one playing your video. You're not playing anybody else's video. You know, it's that kind of thing. You're not looking for an answer and trying to explain why that's not the answer. You know, you're just talking like it has to be this. I say so. I'm not going to demonstrate so. Not demonstrate in any without straw manning. So the only way you make your draconian statements, it can't be particles, is because you haven't looked for the answer with particles that works. you haven't tested your assertion at all.
Point you were actually debating in your head. So you had the time assumption.
Yeah.
So you say you were back then. You were
Because I was brainwashed.
See, he's so unaware. He doesn't even know what Mach gravity is. You know, particle theories that have been around the sage for hundreds of years, and instead he says they're all Casimir effect, you know, which is a charge effect. It has nothing to do with a gravity argument.
To talk about time. So I said, okay, all these equations have mass, they have time. And that's what I looked at. You know, I looked at the equations and I said, okay, here's time, here's mass. And that was just a stumbling block. But at the moment, I didn't realize that. I said, okay, this guy did this with time, you know, like take this Newton's simple force equals mass times acceleration. You look at acceleration, it's got time in there, you know, meters per second squared. And you say,
You got seconds.
yeah, you got seconds, you got time. So it was like I took it for granted. I said, okay, you got time in there. You need to include time. And it turns out that that's a description of what's happening. Now, obviously, you can't say that the car ran because time had something to do with it. Time was not a factor in pushing the car forward. If I have to explain the mechanism, the cause.
I know, but the formulas obviously are not explaining causes. They're explaining effects, and they're just pointing out that it takes time for the car to get up to a certain speed to have a certain impact. It's not explaining that the car has an engine that's providing the energy for the car to move, and then has tires that provide friction that allow it to push against the surface and blah, blah, blah. Push.
I don't need time at all.
That gets weird.
Yeah, it does get weird. No, obviously not. But what I'm saying is that's when you start saying, well, I don't need time. I don't need mass. I don't need energy. I don't need any of those words invented by mathematical physics. What I need to know is what physical objects are involved in pushing that car forward. You know, if someone tells you, look, I'm a technician.
So again, that's a little too simplistic. The math does help in formalizing effects. It just doesn't explain causes, and our explanations of causes have to be consistent with the effects. So I'm just saying they sort of have to verify the mathematics to some extent. The mathematics are pretty good formulations in most cases of effects. So you certainly do have to describe causes that reveal why the mathematics creates the right answer.
Mechanic, you go to take your car to the mechanic, you say, how does a car work? Do you think this mechanic is going to say, well, let me talk to you about energy and force and mass and time? No. He's going to say, look, the gas comes out of here, goes through this tube, comes to the engine. He's going to talk about optics. He's going to talk about physical entities. And again, you know, how did that happen? Did it happen through energy, mass? What was it? No, it was air.
It was pushed. Yeah, you pushed it with force. Yeah, you didn't pull on it.
That I blew against, in other words, all the things involved are objects. And I can make a movie of my theory. I just have to make the air visible. That's all. Once I make it visible, it's for kindergartners. You blew something invisible, which are all these particles. You blew against the paper, and the paper moved. Very simple. It's like the wind blows it.
Right. You pushed it. Very simple. You pushed it with stuff. stuff that doesn't need to go through a medium. Anyway, the photons are pushing mechanism that cause the electrons to act in a magnetic way. Again, the photons are a small percentage of what's happening in the universe. So to get caught up in photons being incredibly effective at creating magnetism would be, in my opinion, kind of silly. Obviously, photons will create current. They'll create electricity. They'll cause pressure in atoms. But again, it's a tiny amount, in comparison to the energy this is doing right now, the gravity, moving planets and stuff, and certainly in comparison to what magnets are doing. If you had to push two magnets together with the force they go together with using photons, you would need like a solar laser. You need not just gigawatts of power. You'd need an incredible amount of power to do it with photons. So photons aren't the most dense part of the energy field. There's just the fact that photons are very specific in their interactions with electrons, and they create very specific consequences that we're incredibly sensitive to. But that's it. It's not a big part of the energy spectrum. It's just a very useful part.
Trees down, or the clouds down, hurricane. We all understand that. We don't need any math, any fancy words, concepts such as energy, force, and mass to explain that.
So going to the title of the video.
Well, you really do need force, and energy is the consequence of pressure and force. So the more force you have, the more pressure you have. So, I mean, these are really important words. So I think it's just silly to get rid of the good words. Get rid of the stupid wave word. Get rid of lots of words, but don't get rid of energy and force. Those are really important words.
About points. The word point used in science.
Let me.
What is the word? I mean, I get this feeling that you're going to talk about the faulty assumption that they're making.
Yeah.
Okay, so this is another thing that can explain part of the balloon argument in the other video. See, because we think of when something radiates, like the sun, it's radiating in a sense from what you could call its center of gravity. You could draw those lines. Now, when a balloon surface is charged, it's not the same thing. You can't draw the charge lines into the center of the balloon, and there's no parallel to it because those alignments are all in this kind of way. They're not this way. They're this way. They're very, they don't care about the center. They're not an image created by a mirror where you have the fake image, right? That is behind the mirror. Okay, it creates an illusion image that's essentially behind the mirror, and you're seeing the thing behind the mirror. Even though that's not technically what you're doing, that's exactly what the rays would look like they're doing. So you have to make that distinction that some things are controlled by a point, a center of gravity, or a point on the surface. But a point on the surface is different than the point in the center of gravity. You can kind of figure that out. These lines are going this way, and these lines will be going this way, and it's going to create a different pattern than the point behind it. So you always have to be a little careful when somebody says a point source or a point particle, what they're saying.
Dealing with assumptions. We have this individual. His name is Ivor Cat. I believe I'm pronouncing his name correctly. No, he came to a friend of mine, and we started just discussing just a couple days ago. So I don't know him well. I don't know all the things he's got coming. I just presented my version of physics. I said, look, the golden principle of physics is physics requires an object. You can't do physics without an object. Yes or no? And an object that which has shape. Yes or no?
Yeah. Well, that's just believing the difference between ether people and physical universe people. So yeah, obviously I would agree that physical implies what it is. So it's named after physical things, objects. But if you want to say physics is some subject that can have some other, everything's emergent from one physical structure. So you have a matrix of dominoes and everything else is just a consequence of those dominoes. Now, yes, the dominoes are physical. So if I make it an ether and make it amorphous, then I've sort of changed the object nature of it. I don't have individual dominoes anymore, but I do still have one physical ether, and I just have lumps in the ether. And so it gets less object oriented because the objects become blobby, and unresolvable. But I don't think it's an important distinction, but I clearly side on the fact that the blobby ether crap doesn't make much sense. It's superfluous. You don't need it. Because to create the blobs in it, you're going to have to do exactly what bullets do. You're going to have to do exactly what clumps moving do. And you don't need an ether to explain their movement. The photons are a pushing mechanism that causes electrons to act in a magnetic way. Yes, I answered that already. When you say photons, like I said, if you extend that to gravitons, okay, I mean what the photons are made out of, the force bits are the pushing mechanism that causes electrons to act in a magnetic way. It doesn't have to be in the form of a photon.
He didn't answer that question, but he had an earlier answer to these questions where he says the following. He says, where is it here? He starts out with this. He says, I start with primitives or a primitive. What is a primitive? It's an undefined word. That's what it is. That's what primitive means. It means you can't define it in more fundamental words because those words indeed require definitions as well and so on down the line forever. So they call those primitives, and what they do, what the mathematicians do, is simply get around from defining.
Okay, I'd love to throw that out, because this just sounds like another perversion of a word we already have a definition for. I don't know why I would change the definition of the word to mean some kind of babble.
The key word they have to define. I need a definition for the word point, and they'll never define it.
To clarify that, for example, the word motion would be an example of a primitive.
I can claim anything as a primitive. I say energy is a primitive.
What they're essentially saying is there are certain words that you can't define because
it would destroy the theories. That's the way I look at it.
Like they can't define the word motion or location because
why not?
It requires other words to define.
I mean, it's wrong to say that. I mean, obviously you can. We know the word motion was clearly invented. We could say we can see the caveman doing it. We can see the primitive man making the word by just saying, well, there's this stuff moving. Leaves fall, this does this, this does this. What is that when things are going from one position to another position? Well, let's call that motion. So this is not a troublesome word in any way. Why is this troublesome? Going from one position to another position is motion, period. We're done. It's not complicated.
And then you go off on a tangent of mathematics or science or something like that.
Yeah,
I kind of get the notion that they're going for, but it's still not. I would call it.
What they're doing is avoiding a definition. That's what they're doing. They're avoiding because they don't want to do grammar. They want to do math. They want to do equations. And I'm saying equations have nothing to do with physics.
Yeah, because
so you can't bring equations in, which we need to explain how a magnet attracts another. I need no math to do this.
Yeah, the issue with primitives is I think.
Well, yeah, you do in some sense that you again have to acknowledge the detail of the output, and I don't think you're going to do that without acknowledging concepts like the inverse square law and other understanding the diameter, the relationship of the radius of a circle with the area of its sphere or the circumference of its planes. I mean, you're going to have to understand some of those relationships, and they're fundamentally mathematical relationships, proportional relationships. So it don't have to be explicitly mathematical, but they're proportional in the sense that 2 is 2 ones. So it is math.
That just shows the level of kind of what do you call it? Avoidance.
It is. It's avoidance.
Not even avoidance. It's underestimating. That's what I'd say.
Underestimate.
They underestimate words and definitions.
Yeah,
it's not held on a pedestal as it should be in science.
Yeah.
It's underestimated. It's not. It's kind of like we're gonna operate on a human body, but we're not gonna use something that's like IVs or something.
And let me tell you why. Let me tell you why it's developed that way. The way it developed is that from the days of Newton, what they've done is they believe at all times that math is the language of physics, and science requires math. That's where it all starts. And so they always were looking for these laws of God, I guess you could call them, laws of the universe, where they say, look, we can explain everything with equations. But it turns out that math.
Well, like I said, there's no point in dissing math. I'm just saying that clearly they should be able to understand that having a mathematical relationship between the knife in the tub and the distance to the bedroom, and understanding what's the probability of something moving the knife from this place to this place and how much time, isn't really going to tell you who did the murder. So, I mean, it's not a complete answer. It's just describing the variables, the connections between the lines between the variables and how they're connected. So it isn't a complete in any way description, and it's mostly a description of effects and has very little to do with causes.
Cannot explain. And, you know, we have the statements. Let's see if I can find it here. Do I still have it? I don't know if I have it. Is this it? Maybe? No.
But it does give elitists a way of making their science inaccessible. So that's another part I think that they like about the mathematics, is it creates a little special way of seeing. They have the telescope, they have the microscope, the math microscope, the math telescope, and no one else can see anything except them. Only the privileged can see with these magical tools, and that makes them feel superior and all that kind of stuff. So as part of that is in there. But clearly any fair-minded person can, I think, should be able to acknowledge that the formulas really do just focus on effects, not causes.
Well, okay. I lost it somewhere. But we had yesterday and the day before, we had Nobel Prize winner Steven Weinberg. We had Professor Donald Simek from Pennsylvania University, Lock Haven University. He's an emeritus professor. They both said the same thing. Science doesn't explain, science describes. Why? Because math describes. So they equated science, meaning physics.
So that's he's sort of saying what I'm saying, just in different language. So he's saying by description, he's saying it's not an explanation of cause, it's a description of effects.
With math. And so they say, you know, you need math for physics. That's why, because that's what they do. They do equations. You don't need math for physics. I need to explain how a magnet attracts another. I need to explain why a pin falls to the floor and not to the ceiling. That's what I need to explain.
What was the argument? Where did the argument start with this Ivor?
Well, more or less here. Yeah, you know, essentially.
What are you trying to get to the bottom of?
I'm trying to get to the foundations of physics. What is physics about? That's essentially what I'm talking about. What is it? Because we don't seem to agree or be on the same page as far as what physics is concerned. So he gives me an idea here. He says, I start with primitives, right? Okay. And by that, he means primitive means undefined words. So he starts with undefined words. That's what primitive means. Means that he can't define his own terminology. Okay, fine. So we go to the next.
So then I would just stop talking, because I just say, oh, come on, we have lots of words that are pretty good. We don't have to use the silly ones like love and random and spontaneous and all this other stuff. So let's just use the rational words, and we can do this.
Step and says, at a point. Okay, he's going to bring Euclid's point here. That's essentially what he's talking about. There is no knowledge about the rest of the universe at that instant. Well, instant or a point? Is point an instant? Instant is a point. Point is location. Location is point. Point is a number. Number is a point. What are we talking about when we say point? Well, obviously, it's a primitive.
Well, whatever. I think I would be saying that's a tiny percentage of the universe. So the universe has got lots of points in it, like bazillions and bazillions and bazillions squared kind of points in it. So obviously, talking about one specific point would not be doing much of the universe. So it's not going to get you very far. You're not going to find a bunch of hoobies living on it. So I'd say screw that conversation as a starting point.
Because they don't want to define it. If you define it as a dot, which is what they put on the board, objectively, that's what a point is, a dot. And you say, what are you going to do with that dot? It's a two-dimensional dot. And they say, no, it's a zero-dimensional. What do you mean zero-dimensional? I see two dimensions. The dot, all dots have two dimensions, a minimum. Maybe they have three, but for sure they have two. And they say, no, look, you're mistaken. See, it's how we locate the point. And we need 0 dimensions to locate a point. Because it's where it's at.
Oh, I don't know. Conventional physics seems to be arguing that there's 4 dimensions, so that, you know, they're not doing this 0-dimension thing. They're adding this idiotic dimension that you're a point in some place in a time dimension. You know, when no, those points are gone. The past is gone. It's gone. It's not coming back. You're not going to it. And the future obviously isn't here yet. So your point is in the present. And that's where it's stuck. And it'll always be in the present, and it'll never go anywhere else but the present. The present will just allow it to move around, and call it the new present, but it is going to be what will be the future. But you can't get there from here. You can't.
And, okay, you need 2 coordinates to describe a plane, 1 coordinate to describe a line, and so on. It has nothing to do with physics. None of that all that geometry garbage invented by Euclid has nothing to do with physics.
What was he trying to explain?
All right, well, I don't know how we'd even say that. I mean, physics just is full of the idea of space and distance. That's it. I mean, the movement across distance is everything that physics is. So I don't even understand why he would say it has nothing to do with the fact that there's a geometry to reality. Dimensions. There are 3 dimensions of geometry. 6 subdimensions. And we're existing in them.
Well, I don't know. Well, let's get to the following. It says there is no knowledge about the rest of the universe at that instant. So a point is an instant, which is who knows what else. It's a non-defined word. There might reside something, whatever something is, because that's the word I'm trying to get to. The word something. At that point, there is something at that point. Now he treats it as a location, not as an instant. And then
yes, and that's fine, because that's essentially who the universe is. There's the state. It's on, off, on, off, on, off. You could almost say that the whole universe is just a little bunch of points, and at the point it either says on or it says off. Says there's something there or nothing there, and it probably does boil down to that. The electron is probably made of something. It's probably made of the force, trapped, stuck together or something, and the force is just on and versus off, something like that. The checkerboard is made of material. It doesn't go all the way down, but I'm just saying there's a certain level of tininess you can get to, okay, of geometry space, and that space is probably in some sort of state that is just plainly binary, on, off.
Be something arriving at that point, at that instant. So
what is he saying?
Yeah, I know. We're having something, which is the word we're trying to get to, and he doesn't pay attention to this. He said, well, we don't care about what something is. We're just saying something arrives at that point. He's worried about location. He's worried about instant. He's worried about, for sure, numbers, but he's not worried about what the object looks like. Is it an elephant? Is it an ant? He said, we don't care. Why don't you care? Don't you care in physics whether it's an elephant?
So the point would be is each one of these little points changes its on and off state by this thing called the speed of light. So at the speed of light, change can move through these different points in what I would consider probably rays, geometry, very straight line geometry. So the smaller you get in the universe, the less circles are a reality. Everything becomes just line art. But whatever, to me, this is not fruitful. This is as unfruitful as searching for the Big Bang is searching for the real, okay, substrate. I hate to even say that. Just because I'm trying to make it clear that there is this idea of the elemental particle. It's elemental in terms of the function of everything we know, the biggest part of the universe. And the part below that is almost a shred of reality. So it's not really that significant to see it in that much resolution. Because you won't see anything. Just black or white.
Or an ant? He said, no, because we're going to treat it mathematically. We're going to say that something, whatever that something is, arrived at that point, at a given point in time, instant, and that's all we care about. We care about the action, not about the actor. Okay? And he continues, I'm familiar with EXH, energy current traveling at sea, velocity of light, right? So which may pass through that point.
Through the point?
Yeah, so he's got energy passing through that point, but he says it has energy density, not energy. So, he's
energy density, not energy. See, when you read these things, there are
So, yeah, that's kind of a bad way to state it. But, I mean, it is sort of obvious. If I move this bottle through three-dimensional space, you could argue if the little bits of space were in little locked positions, the little bit of space here would be saying air, and then all of a sudden it's saying now I'm glass, and now I'm air, and now I'm glass, and then I'm something else. So if you could reduce that to an on and off, energy versus no energy, it would be, yes, there's energy, there's not energy, there's energy, there's not energy. And it's just composing states of energy and non-energy in patterns that create what we call things that look solid, but they're really just patterns of on and off. It really is. You could reduce it to computer science. I mean, I hate to say it just because people take that the wrong way, but I mean, you can reduce it to a completely, you could take it one more step and turn it into just pattern. Everything's just a pattern in the pixels of the universe.
So many things that, I mean, okay, but he's not explaining anything because he's using words that he understands. Let's give him the benefit of the doubt. Let's give him the benefit of the doubt and say, okay, he understands the thing perfectly and it makes sense to him, and it's exactly how Mother Nature does it, right? Let's call it the full mile. But that doesn't.
Did I do something? I turned something off.
No, we're good.
You good? I don't think so. Give me
Yeah, we're
10
fine, we're fine.
You're fine. I don't know why.
Maybe nervous, but
I'm nervous now because I don't know why I can't see myself. Okay, fine.
so we're gonna grant him the benefit of the doubt.
Okay.
He knows what he's talking about, and it's exactly how Mother Nature runs the shop. That's exactly how the universe works. What
Okay.
he used there with energy density and energy, whatever that means.
Yeah.
But that's the problem. If he wants to explain that to me,
Yeah. How does he?
I don't know what he's saying.
He's saying you gotta go to college.
Assuming it's
Well, so that's always the trick, is explaining, right? It took me 7 years to develop my understanding. And obviously I did it the first time. So it's always hard. It's the first time, right? You learn the mistakes. So there's a lot of error in my 7 years, a lot of wrong direction. So I have a view now. I'm looking at it. And I'm trying to paint you a picture of what I'm seeing. And it's kind of an art to it. This art of trying to figure out what's the important part when I try to explain what I'm seeing. You know, frog eyes, this green, you know. And I'm trying to give you the impression I have. And that's always hard, just as explaining anybody's theory. It's physics. It covers a ton of phenomenon and experiments. And you have to explain how, yes, see the lines to these experiments. I have to pick the right experiments to try to make the lines visible, and I have to be fair to the evidence and not hide stuff and not do any of that cheating stuff and have complete answers. It's a very difficult task, and obviously I'm not having great success. But it's very hard to do because it's not it's not just a stick in the mud. And I'm just going to say, well, you know what a stick is, right? And it's up and down, straight up and down, and it's in a bunch of mud. There, I'm done. It's not a simple enough picture for me to be able to just explain it in a couple of sentences. It takes a lot of sentences. Anyway, I would argue the pattern in the small universe is photonic by nature. Well, you can say it. I'm just saying it's just nonsense. Everything has a specific. The small universe is clearly, you have to define it by its structures. There's clearly atoms. The atoms are clearly run by these opposite charged particles, and those particles are clearly manipulated by this photonic energy. So you have to have the scale the right way. The energy is moving the speed of light. The matter bits don't have any innate velocity. They have to be hit by something. They have to be moved by something. Something has to push them somewhere for them to have any movement. So I'm going to go through what else he's saying. The energy hold power. You know, the point of this channel, I'll just let you know, you either attack my theory in some real way, or you explain how conventional physics is right. But that's really my objective here. My objective is not to explain to you personally, tutor you on why your wacky theory isn't the correct one. I'm not here to debunk every crazy person in the universe. I do debunk lots of crazy people like Rational Science and Ken Wheeler and David D. Hilster and all these people. But I am not going to waste my time just looking for tinfoil hatters to point out why I think that's crazy, what you just said. I think that's wrong, what you just said. This evidence points to the fact that that's wrong. That's an awful consumption of my time, frankly. And you haven't pointed out to me why you're worth the trouble. Have you spent 7 years developing this with, you know, a substantial investment in terms of your time, watching a bunch of lectures and all the rest of it, gleaning facts? Anyway, the energy hold power, no matter is there no energy, off, or a lot on, but I curious about drag. Well, I've done videos on drag. It's a complex subject because you first have to understand what velocity is. You have to know what inertia is. And clearly conventional science has no explanation why things keep moving. When this moves, when I throw it, and it keeps going in space, say forever, theoretically, what's actually happening? How does the electrons and the protons know they have to keep going? What's telling them that? Why are electrons that aren't moving different? How are electrons that aren't moving going there different from the electrons that are going there? And I would argue that this is a substantial difference. And the truth is electrons and protons don't keep going. If I have them in my hand, I throw one in space, it won't keep going. The electron will stop. If I throw a proton, the proton will stop. So there is no perpetual velocity through no mechanism. So to overcome drag, a material thing, a complex thing, has to make a little engine inside of it. That means it has to create more force going this way to compensate for the extra force hitting it. And that's exactly what matter does. It has little motors in it, in the sense that more force goes this way, and then when it bounces back, it breaks conservation in the sense that it is able to move its vector for free, perpendicularly. It changes from going this way to going this way, but it doesn't require any energy. And that's exactly what protons and electrons do every day. All right. I've studied metaphysics. Well, I don't care. So I could just block it. The word metaphysics is just saying I've studied religion. So why would I care about religion? For 7 years, and I don't believe in angels. Whether you believe in angels or not, you obviously believe in some sort of metaphysics, some sort of fake, faggoty physics. Frankly, what is a metaphysics? What the fuck is that? Besides a code word for fake, phony, bullshit, pseudo, pull out of my ass, spiritual, godly, made up. You're just saying made up physics. Not interested here.
It's the gospel truth, and it like he just happened to stumble on the way the universe works, and it makes sense in his mind. It doesn't help anyone if he uses vague terminology that I can't then adopt.
But then he says that you got to go to college to.
But that's the irony. It does work. Ken Wheeler is completely, yes, goodbye, is completely successful talking hyperboloid, bullshit, mushy, faggoty words all day long. Just spouts them all day long, and it works. So using jargon that doesn't explain anything, that doesn't say anything, works all the time. That's what the metaphysicians do. They just use jargon. The love beams, you know.
Get a master's degree in mathematics or whatever he studied in order to understand his language.
But then what's the point of even opening his mouth in the first
No, but this
why-
goes
why-
back to what we said yesterday. This goes back to what we said yesterday. It goes to this. There are different levels.
Kind of strange. Okay, so this video is obviously from like a month ago, because he didn't post any videos for a month, and this is the first one posted in a month. So I don't know whether he stopped making videos after this, and this was just a leftover. So I don't know exactly what they're up to.
Okay? So we have the kindergarten level, we have the high school, we have the elementary school, we have the
You
college level.
explain it up to the level.
Yeah, and so he says, look, I'm talking in college level here, but you're still in kindergarten, so you don't understand all my terminology. And so I say, okay, fine. Let's assume we don't understand this term, but let's start from scratch. Start with kindergarten. I mean, what did Einstein say? If you can't explain to a barmaid, you don't understand it well now. What did Feynman say?
Break it down.
Yes, again, and so in this explaining part is, like I said, such a problem, right? Because people are so glued to their, what mommy told them, they're glued to the bullshit they're living by, and they're attached to it like a cat. Okay, it's like I was very attached to my cats, very, very attached to my cats. All right, and it's just a subjective experience, and my cats were clearly better than your cats. There's just no doubt about it. And that's all this is. People are attached to their notions, and they just won't let go of them easily at all. And so it's a real burden to try to overwhelm them with enough evidence for them finally to concede, okay, I'm full of shit, I get it. They really don't want to have to do that. My cat sucks. They just can't. They just really resist having to admit, okay, yeah, he's ugly, he smells, he farts, he's he's got a shitty attitude, his eyes are crooked. Okay, I guess I get it. He's not prettier than other people's cats, and he's not smarter, and he's not any of that stuff. It's right, he's a loser. They don't want to say it. They don't want to admit it.
He says if you can't explain to a 10-year-old, then you don't know it well enough also.
It's
Something
like,
along those lines.
that's my point.
So-
If he uses energy density,
See,
right?
10-year-olds is easy. If I could get the 10-year-old audience, that I would win all over the place, because they're looking for an answer that's understandable. They're the ones who don't want jargon. They don't want, oh, it waves this way and it waves this way, just like nothing else on Earth. They want the explanation that shows, just like, when you stack up 4 blocks, like 1 block on the bottom, and then you get 2 to balance, and then you get 3 to balance. Well, that's easy to tip over. Well, yeah, see, they like analogies like that, stuff they've done. So kids are great at not, you don't have to, they don't have a cat yet. So you don't have to get them to admit the current cat they have sucks. So they're really open-minded in terms of just give me a rational explanation and I'll go for it.
Yeah. Not to be a dick or anything. I'm not saying, hey, define your words or else you lose. Not even with that tone. It's just break it down for me. That's stupid. Break it down for me. I want to understand what you're saying. I want to have in my head what you have in yours.
Yeah.
And you can't do that with vague terminology. If you ask me to explain how the refrigerator works, and I say the Lorgan moved the drawer
What is the Lorgan and the drawer board?
Yeah, now you have to break it down.
Yeah, well, whatever. You break it down, but your breakdown is ludicrous. The only way you can move a donkey is to put a rope around his head. No, there's lots of ways you can move a donkey. So you say things that just aren't true as your premises, and so that's just as bad as jargon. To just say there's ropes going from every electron to every other electron in the entire universe, and somehow we're supposed to imagine that, like, what? Isn't that more expensive than the electron? I mean, the whole universe. How did it ever pay for all that rope? I mean, who roped all the rope? I mean, wow, that's, I mean, the rope universe is bigger than the universe. It just doesn't make any sense. I mean, there's more rope than there is electrons. I mean, it's like having a rope with like a big fat rope, and you have it tied around a hummingbird. I mean, it just doesn't make any sense.
We don't understand, what they're talking about. No, but again, I think that physics.
Primitive.
I always say the following. I think this is the best way to put it. Mathematics is for PhDs. Physics is for kids.
Yeah.
If you cannot explain, and I think Einstein and Feynman said it properly there. If you cannot explain it to a 10-year-old.
Well, I just think, okay, you've redefined metaphysics now as metaphysics as the word means to study physics as a field itself. That is superfluous lunacy. So do we call real biology, where you're doing the study of biology, metabiology? Does anybody do that? Are there meta-architects? Are there meta-engineers? I mean, that is insane mush. Sorry, Antelope, but I mean, it's just insane mush. How come we don't need to meta any other discipline? Why physics? Sorry, just a bullshit answer.
Then you have no idea what you're talking about. Okay, you're not doing physics. You might be doing math. You can talk about Einstein's field equations. You can talk about, Niels Bohr and all his equations, and Heisenberg and Schrodinger and whatever. You have no idea what physics is about. If you want to talk to a kid, you got to talk physics. You got to say, look, this is how the farmer pulls on a donkey. You pull with a rope, and everybody will understand. And I can make a movie of that. And if I start saying, look,
I shoot ping pong balls at its ass, a paint gun. It gets up and it moves.
You need to understand what energy is. You need to understand what mass is. And then you take mass and you push that with so many, and here's the equation for it, etc. You lost the guy. The guy can't follow. You say, well, you got to take a course in physics at the university level. And then after all that, they still insist, and they say, they give you the fine print or the closing argument and say, nobody understands quantum mechanics. No kidding. If they don't understand it, certainly I'm not going to understand. Mother Nature's not going to understand it. You can't explain quantum mechanics to Mother Nature. Period.
I think the issue that we're kind of going around are the three kind of forms of communication of math, words, and movies. Where math and words really just kind of convolute me.
Whatever, like that. That just sounds a little silly, as those being the elements, of reality's atom. Yeah, movies are great, demonstrations, documentary. I don't know, something, but let's not aggrandize any of this stuff. I mean, that just doesn't make. Words are incredibly important, incredibly powerful. They do have good definitions, and there's lots of good words. So this is just horseshit, and some really crappy words. Metaphysics.
Giving you information. If I just show you the movie of what I mean,
right?
You could misunderstand.
This goes to. I got to interrupt you there because Tom Aggard yesterday said it properly. He said the following. I got to read it over here because I don't know why I can't see my image there in the OBS. He says the following. So let's wait for it to come out. It's rational if you can visualize the mechanism. Logic doesn't need to be visualizable. So he says there's a difference between. Yeah, he said that yesterday at the end. He says there's a difference between rational and logic. Okay, he says.
This doesn't make any sense. It's rational if you can visualize the mechanism. I can visualize Daffy Duck having a fist fight with Tweety Bird. Doesn't mean it's a rational explanation of something. Logic doesn't need to be visualizable. I think it does. just as every fact needs to sort of be visualizable. If I say torture, you connect it to an image of torture. And it's the facts. Torture is bad. Well, you know it's bad because it's got all the aspects of bad. There's screaming, there's psychological bad, electricity, all kinds of stuff is happening. It fits the word. So yeah, I just don't, that's just mush. Have his own theory at all? Well, clearly, yes, he has his own theory. It's called rope theory. He thinks every particle is connected to every other particle in the universe with a rope. And the rope twists, and that's a photon, and it pulls things together. And if it untwists, they go apart, I guess. Something like that. And the ropes jump. Sometimes they swing. And when they're swinging, they hit each other, and you can have a magnet or something. He has a theory, but it's so irrational compared to the rest of his conversation. So everything else he talks about, he seems completely rational. And as soon as he talks about his theory, a giant tinfoil hat goes on his head. I mean, he just turns into a nutter.
Rational is what you can visualize. I make a movie of my physics theory. I visualize it there on the screen. And I don't need to use a single word. I show you how a car works by showing you the whole movie, a silent movie. We'll bring Charlie Chaplin to do it for us, okay?
So he makes these little short movies, 2-minute long movies, and he shows, look, the only way you can move a donkey is you have to put a rope around its neck and pull it. When obviously the rope is pushing on the donkey's neck.
It does not need to be visualizable. Logic, you can say if A, then B.
That's what I said yesterday.
Yeah, and you can do it with computers. Computer doesn't have to visualize anything. But rational, he's distinguishing rational from logic. That was the issue.
I added one more word because there's a difference between imaginable and rational. That is how I would define it. Imaginable is just any shape you can have in your head. Okay. Rational is taking something in real life and then making everything that's invisible visible. When you want to explain something, you can't. I mean, yeah, you can visualize anything.
I probably don't need to play this all the way through, but since I'm so close to the end, I might as well.
But when you use the superpowers, now how are you going to rationally visualize it? You can't do that.
And that's one of the issues that, I was also going to present an example. You can present a theory involving angels. You can say, look, here's an angel. You're showing this human with wings and a little cup on his head, a little ring or whatever on his head. Okay, plate or ring. And so now you say, look, here's my theory. My theory is that angels move the earth around the sun. I can make a movie of that. I can make a movie of angels moving around the sun.
And it would make just as much sense as a movie of ropes going from every single particle in the universe to every other single particle in the universe. Yeah, just as bad.
And you say, okay, I understand your theory.
It's imaginable.
It's imaginable because I can put it on the screen. But now let's look at the assumptions, okay? We're going to go, now we go back to assumptions. And we say, okay, hold it. I got a couple problems. Why does an angel have wings? I mean, wings on Earth, birds and so on, because they use them for air. And out there in space, there's no air, so why do they have wings? That's one issue. Another one is, hold it, these guys have super...
Well, they're ether wings, so they're bent space wings, so they move bent space. Yeah.
Powers, like, they have so much, they have little mass, because you're a little angel, he's just a human, maybe he's a little bigger, I don't know, and he can push the earth around. Well, where does he get the mass to push the earth around the sun? And so you have questions about the assumption, not about the theory. The theory you can understand. You can say, okay, I see what you're saying. You're saying the angel pushes the earth around the sun. We can all understand the mechanism. We can't understand the assumption, the superpowers, why he has wings.
It pushes it into the sun, not around the sun. So, but whatever. It doesn't really matter. I guess you can make the angels push the earth this way and this way.
Maybe some other issue.
Well, why? More to that point specifically.
Why is floating in around his head?
Yeah, but specifically, why can't we understand it is because to understand something, there's a key invisible thing that you have to make visible. Right, there's some invisible mechanism. There's something that you didn't see.
Maybe invisible.
Exactly. If you have the car hood closed, you're not going to understand anything.
You got to open up, show them.
Right. And this happens because of a force, little photony like stuff moving the speed of light, hits it, moves it down. That's how it's happening. Can't see it, but it's there. You can see what it does.
Show me exactly every single bit that's going on there.
Oh, the
magician is also good. When he does, why does the magician have the box at all?
Yeah, I mean,
because the whole point of magic is it cannot show you
That's right.
It's the height of part of it, so that you go, holy crap, how do you do it?
Is that what Mother Nature does?
There's a magician called Penn and Teller, which they do this one trick with a box where it's two magicians, and one guy kind of pops out on this side, he pops out on that side, his feet are over here. Like, how's he doing this? And then after they do the trick, they do the whole thing with
They explain it?
Yeah, they do the whole thing with the
Open box.
glass box where you can see exactly where he's going or where he's putting his feet, where he's putting his hands.
Is that what Mother Nature
It's
does?
hilarious. No, but that's the point of science.
Yeah, but look, here we have two magnets, right? And Mother Nature's fooling us. She said, look, I can do magic. I can make these things come together from afar. Here goes the poles already, okay? And it's holding it, right? And you say, well, how did you do that, Mother Nature? Well, I'm not going to show you the visible parts, the invisible part. I'm not going to make them visible to you. I'm going to let you break your brain to see, figure out how.
Like I said, it's not that hard to see it, so you can just imagine that, oh yeah, there's little force coming from all directions, pushing pressure from all directions. And when you put two things in pressure, they'll tend to move towards each other, and that's the pressure that's pushing the magnets together, but you've removed the pressure between them because of the magnetism. And when you reverse them, there's more pressure between them, and so they push against the force that's pushing them together, so they push away. There, it's not that bad. It's not that hard to do.
I did this magic.
That's right. The whole point of explaining is making something invisible visible. If I say, if a really loud sound happens, right, in the kitchen, and you go, oh, what was that? And I say, oh, I saw it. It was the plate. It fell on the ground. Then you kind of go, okay, in your head, you can now visualize the thing that fell
down, right?
Right? Now
you say that was a spirit?
Yeah, so you could argue that conventional physics has done a really poor job of the transparency of showing the trick, showing the pigeon in the sleeve and then popping the pigeon out and all that. They're not really showing you much at all. There's a little bulge where the pigeon is. There's some tiny little evidence there might be a pigeon in your sleeve, not much, blah, 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 blah. So it's just not enough evidence to draw conclusions. All right. Oh, the rope theory is all his. No wonder. He's given a terrible explanation of everything so far. Well, I totally disagree. I think these conversations are really good. I think there's a lot of subjects that are broached about how we think and taking things seriously, thinking seriously, and using words seriously. I wouldn't say this was their best video. A lot of junk, the waste of time about assumptions when we're really talking about weak evidence, but whatever. So I just don't agree with you that everything he says is garbage. He makes very good criticisms of the weakness of conventional physics.
Yeah, if you energy, you can't just say. I mean, you have to put some object in the effect of something.
Hopefully, that's what I'm saying. You got to make there's an object between two magnets, and you got to make that object visible if you want to understand the theory.
Yeah.
If you put nothing there, for sure, no one's going to understand the theory. And if you put a concept there, such as energy, mass, force, whatever you want.
Those aren't concepts. Force could be made of a real thing, a force, a mechanism, bullets. So again, it just implies as if the force has no meaning, that anything's a force is an invisible man. Forces can be real things, and we're affected by the force of a wave hitting you. It's a real thing. We understand that force, that pressure.
Put in there that's a concept, information, love. No one's going to understand your theory. For sure.
There's something invisible you have to make visible.
Love isn't even a concept. Again, it's just an amorphous catch-all word for 1,500 different kinds of things. So it's not a concept. It's a mushy word with no explicit definition.
Yeah, and you can't make a concept visible.
But that goes back to
you can't make a concept visible.
And you can't make a concept visible. But it kind of goes back to what I was talking about with movies, words, and math, where maybe at physics conferences, there should be an unspoken rule of no complete silence. No one can talk. Anytime
just push it out the board.
Yeah, show us a movie. And then we get the next presenter. He plays this movie.
I got your idea. That's a good idea. We're not going to accept blind people, but we're going to accept deaf.
Only deaf people. Everybody comes here blind.
No, you can't hear it. I don't want to hear your explanation. I just want to look at your movie.
Anytime there's an
and again, we know the movies don't mean anything, because they'll show you a movie like Dr. Quantum. They'll show you a movie of something that doesn't really exist. It's not the way it really happened. It's crap. So the movie's not going to help any.
Yeah, what are you going to put in each frame? You got to put an object.
That's my point. Anytime you want to explain a phenomenon, an effect, any effect, you hear something, you see something, you feel something. There's something, and you okay, let's not see, because that's the whole point.
Yeah.
If you feel something, hear something, taste something, or smell something, but don't see it, now there's something to explain. Yeah, that's the whole thing. Explaining is literally that visualization where you
magic. I'm doing it with magic.
What can I imagine in my head? What's the thing that I put in my head to explain?
You're just explaining the fact that things do certain things that sometimes you don't expect, like a water dripping off of a board or something, and it clings to the surface and slides underneath and then drips in a wrong location. So it's a little bit complicated. It's a real thing, but it's not something you could just intuitively say, oh, that's the way it happens. No, you have to know a little bit of the physics and why it happens that way. So physics is a little complicated. You do need words. You do need to explain these different phenomenon. Again, they're real phenomenon. You have to explain them. And this is, in my opinion, explains nothing. Ropes explains just about nothing. Real. Nothing.
In that effect, if something pushes something and I don't see it, okay, how do we explain this? If I smell something, where does the smell coming from? You don't see it, obviously. You're just looking for something invisible to make visible to explain.
I like the current. I like always the curtain. The curtain moves, and your friend says, "Well,
the rope twists." Who's twisting the rope? Where's the energy come from? Who ate a bag of Wheaties to get the energy to twist the rope?
The reason the curtain moved is my great grandmother's spirit is in the room, and she moved the curtain. And you say, well, maybe if you close the window.
No, but
right? I mean,
anything, because for example,
there's a different explanation.
You extrapolate anything that you don't see. For example, if you have a pain in your stomach, right? You feel something, you have an effect,
and you can't see it.
And you can't see it. So what you're trying to do when you try to explain it is you're trying to make, okay, what's the visible thing? Obviously, you can't see it, but you're trying to imagine it, right? You try to imagine your stomach, and
you see it with your brain.
If I put a rock in my head, if in my imagination, if I put a rock in my stomach, right? Would it explain this sensation?
Right. So you put a rock. You simulate it with a rock.
Yes. But there's no point, because now you're not getting to the core answer, right? Because these things are going to be caused by things that aren't going to be obvious like that. They're not going to be, well, there's an ice pick in my stomach. No, there isn't. It feels like that, but that's not what it is. So what's the point of this mush? It requires detailed explanation. Again, the picture is not. The mechanisms can be simple, but the output can be complicated. And you have to explain how the simple mechanism can make the complex output.
Hey, is this causing the pain? Then you say, no, let's try bacteria.
Yeah.
So now you go bacteria.
Color brand or whatever.
Right. You say, could this cause the pain?
But you're essentially trying to make, you're never going to see it.
You're simulating with whatever ideas come to your mind. You're trying to explain what's causing the pain.
And explaining is literally making something invisible visible. And not even like literally, just in your head. Just having something to imagine. If you can imagine it, you understand.
And with that, we will see you tomorrow at the same time, same station.
And tomorrow our class is just going to be movies. No
tomorrow we're not going to talk at all. Tomorrow we're just going to
slapstick. Charlie Chaplin out here.
We're going to put Charlie Chaplin silent movies and whatever we find before 1927 when they invented, sound.
Someone said this to me when we were talking about magnets. The concept shape comes from.
It's sort of irritating because he titled this video, "What's the Point?" So it really wasn't on that subject. It really didn't, I mean, it's just kind of annoying. His videos aren't titled very well.
Visual and tactile perception. The inherently unseeable and untouchable need not have shape.
The inherently unseeable. No, Art. It's not an issue of whether we see or not. We remove we kill all observers in physics. There are no observers in mathematics. There are observers.
But the point is, we're all trying to observe something without shooting photons on it. So we're trying to approximate its function based on effects, and we're trying to make it into something we actually did bounce photons off of. We're trying to see it as it is with the detail without ever hitting it with a photon and seeing what it looks like. We're just trying to guess right. It was a good discussion on magnetism. Just didn't feel like he explained the mechanism behind magnetism. Well, he doesn't have one. I mean, his is jumping ropes and all that kind of crap, so it is a pretty horrible explanation, actually. I'm just saying, yes, I agree with you. I'm just saying, this is what people should be doing, okay, are these kind of conversations. So I have nothing but admiration for the quality of the conversation. It's just unfortunate that some percentage of the conversation is about its own theory, which is a tinfoil hat pile of crap.
In physics, we have no observer, so we don't have to see, we don't have to touch. We have to imagine. We see with our brain. An object, by definition, is that which has shape. So whether I can see it or not, I can't see the air. Here it is again.
Exactly. So we're making a model in our head, and we're just trying to be accurate model makers. And we can know what inaccurate model making looks like because we can watch a religious person do it wrong. So we can know that jumping to conclusions and jumping the evidence and doing all that kind of stuff is closing the door after the horse has left the barn, or all the cliches. We can know how to not do it right. And I'm just saying it's glaring in conventional physics not doing it right. Claiming you have the most predictive, greatest theory in the history of mankind when it hasn't done any of that shit. I mean, overstating the quality of your evidence is just one of the most fundamental violations of the rules. Claiming your evidence is solid when you haven't repeated the experiment that's critical to it. Misdescribing the evidence. These are overt violations of doing it right. All right.
I can't see the air, but hopefully there's a physical object there. I'm not doing this with magic, believe me, okay? Please.
Right, so the air is invisible. You can make it do something. It can transport impact. And here he can't understand how gravity could be invisible bullets pushing everything together. I'm just saying, what's the difference? It's invisible, you can't see it, but it does do things, and it does them quite obviously.
Believe me.
Is there such thing as untouchable?
Yeah, they were in the 1950s, the Untouchables.
Oh, yeah. In physics.
Yeah, I mean,
I don't know, but seriously, there's no such thing as an untouchable thing.
Well, it is. It's beyond. Well,
it has no effect.
Untouchable is a touchy word.
Yes, touch is a messy word, because right, material things never touch other material things. They always just bang into the force of the electrons. So electrons never touch electrons because it would create an infinite amount of pressure. So everything always bounces off the force. Matter never touches matter, and force never touches force.
What are we talking about tomorrow? Yeah, in a nutshell, just off the top of my head, there's no such thing as untouchable. If it's untouchable, it doesn't exist. Kind of thing. Whereas if it's untouchable, that means it has no effect.
Yeah, the problem with the touchable is that you have to run an experiment to find out if it is touchable. Like the star on the other side of the universe. I can't see it, I can't taste it, I can smell it, I can't do anything with it. Is it touchable? Well, let me run the experiment, I'll tell you.
Yeah,
so it's like you need an experiment
thing. I'm just talking about logically. If there's something that's untouchable, right? Assuming we do.
You're going to touch it from a billion light years away with exactly the same thing you're going to touch it with if you're a foot away. A photon, a piece of energy, a force. So the force of light coming from a star a billion light years away is just as strong, that little piece of force, as it was if I was standing right next to it. It hasn't changed any. And if I was standing right next to it, there's nothing different that's going to push on me than something just like that little bit. Just more of them. So the closer I get, the more of those little things I hit. So in a sense, I'm touching it just as much here, just in the same way, the same mechanism of touch from billions of light years away as I would touch it if I was right next to it. Obviously, I'll be hit by so many more of the little photons, my hand will be burned off, but point is made.
For fact, whatever, we did the experiment, everything. If it's untouchable, what's the point of you talking about?
Yeah, but hold it. It's a big word because now we have to define what you mean by touch. And we'll get to that tomorrow. Touch is a very big word, especially for the rope model of light and the atom. You need to know what touch means because it has to do with the issue of tangling. People ask, well, don't these ropes tangle when they cross each other? And before they tangle, they must touch, right? Because, it's like, just visualize it for a second. Two ropes coming together, right? First they touch, then they can go through each other or do whatever they want. But first they must touch. So we have to explain touch before we explain tangling. And we'll
not go through each other. Well, sorry. Not even close to a chance of a sale. So, yeah, good luck with that.
Do that tomorrow. We'll see you then tomorrow, same time, same station. Bye-bye.
All right. Semi-entertaining, but, not very really. Okay, it was some of it tedious, long, all that kind of crap. Very good test, though. This computer has survived, didn't crash. Everything's still working, right? It looks like it's working. That sort of looks like it's right. I don't know. Something's wrong. The placement of it, I guess, is disturbing me. It doesn't seem like it's the whole image. Like I'm not in it anymore. Oh, okay, I'm over there. Okay, so I'm still there. So we'll just pop up the writing thing, I guess, and we'll pop that down. So we'll pop that down. There's the writing stuff. Okay. So I don't think we have anything else. So if anybody wants to comment or say something, and then I'll get the hell out of here. So if you have any comments, paying attention for a minute. But I was paying attention before. It's we're obviously short of participants as usual, but I can only do my part. I'm showing up, you know. So 30-second warning kind of thing and such. Yeah, so I am using OBS again. And yeah, it's just unfortunate that it doesn't like my sound card. So it creates a noise with anything plugged into the sound card. But if I use the separate external mic, then it doesn't pick up as much noise. But this mic works for the live room, so I can use it in a live room. So it's just really weird. But anyway, not your problem, just technical issue. Let's see. Apparently a lot of people doing physics have such great intentions. Yeah, they have passion, but I don't know about intentions. Because like I said, there's so many people, like the free energy people, who are stepping right over the truth. I mean, they're stomping on it and grinding it into the ground. They're so aggressive in denial. So they're really denialers. And you know, stuff that they just can't be denied. And they're just, you know, they're aggressively trashing facts to get where they want to go. So I can't call it great intentions, but are also just unfortunately wrong. So yeah, there aren't too many who are wrong, in my opinion, in some kind of honest way. Now, I like the Franklin Hu guy, seems kind of honest. There's some people who seem to be, yes, I'm convinced this is the way it works, even though it's wrong. It's stupid, I think, some of it. I don't think he's doing it because he's trying to create new energy or do something, you know, he doesn't have some ulterior motive for being an etherist, I don't think. But I can't be sure. Feynman sometimes was an example. That guy too. Yeah, Feynman, I would say, is sort of a good example, but he's another guy who I think he had enough reason to know how weak some of the evidence was, and he just didn't have the courage to say it. So that sort of bothers me. And he did play along with some notions that were just playing games with reality. The old idea of time travel electrons. He should have just admitted, I'm just having fun. And this has nothing to do with the truth. And instead, he allowed it to become some kind of real mathematics when it was clearly just synthetic. We can make it do this, you know. We can make the math do all kinds of things that aren't bound by reality. And he should have just admitted that that's the danger of the math, is that it does allow you to, when you step beyond the evidence, you can do math that will allow you to create a fake universe. And as long as there isn't something glaring saying, you know, that breaks conservation or that breaks something, you don't know that it's not overtly wrong. It's just substantially made up. Scuffed voltage as potential differential. I don't know. I should just say, how could somebody type that? Scuffed voltage as potential differential. Booger, wiener, fingernail, frog butt. Were we just playing the random word game? I mean, you tell me, what the fuck is Randy Rickles? So this is probably the cowboy or some other trolley type person. I'm sorry, I just sit here and I say, how can humans, what raised these people? How do they think this is a productive way to interact in the world? I mean, I just can't understand it. I mean, you think the criminal element is kind of a small percentage of the human race, and the complete imbeciles are a small percentage because, people aren't getting killed all over the place. But clearly there's a preposterous number of imbeciles walking around. Ew. Force doesn't touch force, correct. Matter doesn't touch matter, yes. Force touches matter, and matter touches force, yes. That's the way it works. That's the game. Matter doesn't go somewhere unless it's forced. It's that simple. You have to force it. Yeah. So, awful lot of videos today. Hours and hours. It must be 2 hours. It's another 4 and a half, I don't know, 4 hours of videos in one day. It's gonna kill you people. Some of you it'll probably kill. I'm sorry about that. Didn't mean to kill you. Not that it's going to do you any harm or good, right? Because you're dead. So, yeah, probably did you a favor. Probably. Let's see. I don't know what that is. Oh, good. You retracted it because I didn't know what it was. Oh, you wrote it again. Epiricus for the win. No, I don't really want to do any of that. Let's go all the way back to the people who hadn't figured out toilet. And, they'll tell us what the truth is. Not saying that the ancients didn't have some, they were very insightful for their time. But it's all it's got a lot of error code in it. A lot of error code. First computers, lots of errors. Yes, well, the odds are, like I said, is if you people don't post your comments, I win. That's how funny it is. Because yes, you often say things that are poorly structured, insanely founded. I mean, just overtly random, Randy. No. All right, a few more seconds. Type fast. You're typing, finish the sentence in the next 20 seconds. All right, I will bid you farewell. Okay, so you've all had enough too. Good. We're all agreed. It's time to go. Okay, so till the next time and such. Glad the technology appears to be working. And good. Have a good day. Thank you. Night. Thank you. Likewise and such. So I think I've accomplished. I did it. Yay. Bravo. Till next time.